Morning, Claire.
Morning.
Got some other people come on in. Minutes. I don't see nobody here. I guess we could get started. What I'll do is, well, good morning. What I'll do is, let's look at, everybody took the test. Everybody was able to take the test. So you should be straight with that. What I'll do, let's look at the program. Some people still not turning in the header file. Some people turning in the header file and not actually loading or calling the header file function when they actually have the code written. Okay, but let's look at the program and see what they actually entailed. All right. So the first program we had looked at on last class period, it said to write a program that allows you to input 3 integers, calculate, and print the product with the now you got to know the product is what? Multiplying the numbers by each other, right? And getting a sum. And then once you got that sum, or not that sum, that product, then you want to determine whether or not it's even or odd. Now, like I said, we was using the if statement, which is pretty much in this new chapter, but we went over it, and if you look at notes, you would have been able to see it. So let's see. Let me go to Visual right quick and open up a program. All right. And then, like I said, I gave you the output format. All right. So basically, in this program here, it come up. All right. So this is, I'm programming this up already. But basically, you have three numbers, all right, that you're going to input. Let me take this off. So I'm going to declare three variables, but then I can declare a product. All right. All right. And then what? You would have C out, whatever the inner, if I can type, first number. All right. Well, all right. And then you would do Cn what? I did something. And then Cn num1. And you would do that for each variable. And I'm not going to do the whole program, but I'm going to show you, how you were supposed to go about setting it up. So C out in a first number, Cn num1. C out in a second number, or whatever the label was supposed to be. C out in a second number, then Cn num2. C out in the third number, Cn num3. Now, once you did all your Cn's, you've got your number, then your expression would look something like this. Whatever your variable was is equal to num1 times num2 times num3, all right? So that would take the num1, num2, num3, multiply them, store the value in product. But once you got that, now you need to determine whether or not the value is even or odd. Now, the thing is with that, I think one person, they used an if statement, but they didn't complete the if statement, all right? So normally you would do something like if, this is one way, you can say if product modulus 2 is equal to 0. See, what one person did, they just say prod modulus 2 and parentheses. So what you're doing now, you're just checking to see if that particular portion is either a 1 or 0. If it's 1, it automatically makes it positive. All right. So that means that I could get any number. As long as I get a number that's not 0, it's gonna say what? That is even. All right. So if I divide a number by 2 and then and have a remainder of 0, then let's see, product mod 2. Yeah, product modulus 2. If that equals 0, then we know that what? C out number is even. And I gave you the specs on how to output it. And then you would have else, because if the number is not even, the number is what? Odd. And I gave you the specs. All right. So that's how that program was to be written. All right. And like I say, I didn't put in what your header file, where you would do the pound include whatever your .h file in double quotes, and then you would call the function, the head, whatever we use head. Remember, normally we would use head. So whatever your function name was in your header file, you would have to have that in there to actually execute that portion of that header file. So that was the first program. Anybody have any questions about that one?
No, sir.
Okay. All right. The next one. Let me see. We'll go back. The next program. All right. It basically. Okay. That's what we did. The name. Now I'll kind of explain that one to you, and I could kind of show you syntax also. All right. So this one would have. Well, you would have a variable for name, and name is of what data type?
String.
Could be string. Have to be a string because it's multiple characters. We have job title, also string. Then we have wages, which is what?
An integer.
All right, not it'd be like float, right? Could double or float because what? We need to do our format. Now, if you created a variable and you made it int, and you try to do the set precision and the fix on it, you'll never get the decimal place because it's integer. But if you had it as float or double, then you can get your decimal places. All right. So the name string, job title string, wages double or float, hours worked double or float. Then what? We have another variable, a value that we need to calculate, which is gross pay. Another value that we calculating, which is taxes, and then another value we calculating, which is net pay. All right. But then we have something that was given, which is the actual deductions for the taxes. All right. So in this program, when you read in the name, you should have did what? Cout, enter the name, and what command you would need to use in order to get the first and last name. You had cout, but what goes before?
Get line.
Get line, remember? Right. You have to use get line. If you did not use get line, you could type in a first name, last name. When you hit enter, the first name was the only name that was going to go into name, and then the last name was going to go into job title, and it was skip. So you have to remember that. We had talked about that. So use the get line for this one, use the get line for this one. Now to read in our data, our numbers, we just can use what? CN, right? CN the wages and CN the hours. We could put them in with no decimal place. It didn't matter. When we display it, we're going to display it with a decimal place. All right, hours, same thing. We could work 80 hours or we could work 68.5 hours or whatever, because make it float. So now, in this situation, like I said, we had to have our, I'm gonna take this out, somebody had they just didn't do using namespace, so they had to do all the standard library loads. All right, so now in here, let's say, I need to add something else. Okay, pound include string. All right, so you have this. If I can take, all right, pound include string. All right, and it's kind of congested. Okay, so we'd have what? We could say string, name, and J title. All right, I'll say title. All right, so I have those two, and then I'd have to change this to float. All right. Then I could say float or double, and I could say what we had, wage, hours, GP. I'll just put GP, gross pay, taxes, and net pay. So I just created some short variable names, but your variable names can be longer, long as they're one word, doesn't begin with a number, and they are no special characters in them. And then, like I say, CN, cout in a name, all right? And like I said, I wanted the first and last name. That's it. But like I say, so my description here is not really that meaningful, but we'll do it like that, name. I'm just showing you how it works. And then cout.
Well, you got to do the get line.
Yeah, the CN dot get line, right. I mean, the get line dot, yeah, you're right. Because get line, CN, and what it is, name.
Name, yeah.
All right. So now,
Well, you don't need that stream after it.
Right, correct. Now, so now we have this one. Okay, let's see. Wait. CN. CN get line. Let's say CN get line name. All right. So now, we have the name. I can't move my mouse. All right. So we have the name. Then here I can say enter. enter title, and we're gonna say job title. All right, and then what? Get line, CN, and that will be title. All right. Because we could create the variable to be any name, but we know when we outputting our data or referencing it for the user, we need to be more descriptive. That's all we need to do. So here we can say cout enter we can say wages. All right. And then we have CN. And now you just use the CN and you say wage. All right. And then what? Cout and enter hours. All right. And like I said, and you could enter the information in any order that you want to, but you have to make sure the variables are matched with the heading and the data type. All right. So hours, and then say CN hour. So now this collects the data. Okay. So this part here just allows the data to be captured and stored in the computer, so that now we can do our formulas. So if you look at it, when you're writing code, first of all, you need to establish what all variables you need and their data type. Once you get all that, and like I say, you don't necessarily have to have them all, or you're gonna get an error. But if you're going through it and say, oh, I need to add another one, just go back up and add it. You could just add it. But you should know somewhat what variables that you need. Then, in order for your program to do something, either you're going to have these variables initialized to a value, or you're going to have to read in the data. And later on, we're going to see how we can read in from a data file. But don't worry about that now. We're doing it from the keyboard. So here's where the data is going to be collected. Once the data is collected, now we can go in and do some calculations. So now I'll just delete this. So what? Now we need to know how do we calculate gross pay? Or not even that. We need to know the order in which we need to calculate this information. Because the first thing we need to find is the gross pay. We can't try to find the net pay before we find the gross pay. Everybody agree with that? Right.
You got to do wages times hours.
Right, correct. So all we have to do is say, okay, GP, right? And is equal to the wage time hours. Now, in other programs, they might have the variable name gross pay, they might have wages, and they might have hours worked as variables. But you need to know when you look at the program, oh, this is my representation for gross pay. This is my representation for wages. This is my representation or variable representation for hours. All right. So that's going to get our hours. Now, what you can do also, and this is just program documentation within the program, you could just do something like / calculate the gross pay. All right, and that's just something where you have a little comment to say, okay, this is what I'm doing at this point. All right, because sometimes if you have a larger program, you may want to keep track of what you're doing at certain stages. So when you go back and you have errors or whatever, you don't have to try to read through the entire program to get to that point to know what's going on.
Mr. Sylvester.
Yes.
I believe there is a way to make comments more than just a single line.
Yes, there is. Yep, there is. Okay. What you do? Well, go ahead. Go ahead.
I was just gonna ask if you could show me.
Okay. All right. To do that, say for instance, I just want to enter job name and job title. I want to take out these two inputs in the prompt. What I can do is anywhere before that statement, on that blank line or before the statement, I can do /*. You saw what happened? And then I can go down to where I want to end it and do asterisk Oh, my fault. Asterisk slash. And now what it did, it blocked out everything from this point to this point. So if I run this program now, it's just going to allow me to input name and job title, and then it's going to try to do gross pay where I'm going to get an error because I'm not inputting anything for gross pay. And
gotcha. Okay.
Right. So and you can put anything you want. You could put paragraphs of information, as many lines as you want, if you wanted to describe something you was doing. You understand? Right. Yeah. Or like I say, most time what more experienced programmers do, they'll say, man, I'm getting this error on this right here. So let me block this out, because it's not important right now. And I'm gonna see if my other part of the program is working. And so they'll kind of maneuver that way. Right. Yeah, it kind of helps rather than try to delete everything out or comment line by line. Right.
Got to retype everything.
Right. There you go. Right. That's right. All right. So now the gross pay. Now, before we get the net pay, we need to find out what our deductions. So taxes. And we could have created a constant variable. I could have done something like this. A constant variable. You just simply say const, and you give it a data type, and I could say double, and I could say tx because we got tax already. Tx is equal to 175. I forgot what it was.
172.
172. So that's going to be tx going to equal to this, so that anytime I reference tx, it already knows what that is. So that in my program, if say you're writing for a bank and you've used tx say 100 different times in the program, because you have different places where you actually calculate a tax, which is the 17.2%. If they change that value, what you can do if you have it as a constant variable, all you need to do is change the value in here, and everything else in your program is automatically still fixed.
Right.
So you don't have to go back and try to, I need to change 0.72 or 0.172 everywhere in my program. And you might miss one, or you might type a wrong value, and now you're more susceptible to having errors at certain points in your program.
Yeah.
Right. So now TX would be equal to the growth, huh?
Yeah, I was gonna say you could do the gross pay times the TX.
Right, and that's gonna take whatever the gross pay, the 0.172%, and store that into store that into tax. Right. Now we've got the gross pay, we've got our tax deduction. Now we can calculate the take-home pay. All right, and now so our net pay would be equal to what? GP minus right, TX. All right.
Or
so you see,
wouldn't it be TAX?
Yeah, TAX. You're right. Because that would give me a whatever. If I had $800, it'll just subtract whatever cents, 17
cents. That's a tax I can get behind.
Huh?
That's a tax I can get behind. Yeah.
Oh yeah. But you see how you got to understand the process. And if you never had a job, what you'd have to do, you'd have to go talk to somebody. Hey, how do you calculate whatever? How you do whatever? And kind of get the gist of it. And once you get the gist of it, then you can apply it to the program. Right. But sometimes you're gonna be working for a company or whomever, and it's some type of practice that they're doing or procedure that they work with, and they do certain calculations a certain way or whatever. You may have to go to that department, sit down with whomever works with that, and get them to go through it, so you can understand exactly how it's going on, how they calculate, and then you say, okay, now I can go and sit down and write the code. All right. So sometimes it takes a little leg work. So now once we calculate all this, now we had it to where we had our columns. Remember? So our name was I think 30. But I'll just do a C out and show you. All right. Well, first of all, we had set W and columns of the column width. So I needed to load what? man IP, right?
Yeah.
Because if I didn't do that, I'm gonna get all kind of errors. So you got to see those type things is like over time it should come to you natural. Hey, I got to load this header file if I'm going to use this command because you will get errors.
At
Right?
some point, wouldn't you just always include the most basic of header files?
Maybe, but okay. Say this: if you say if you're writing a program and you're not using strings, you know what I'm saying?
Well, yeah, I mean, like on like say for like a job, like you're doing a much bigger program
Oh
than
yeah,
just you basically just always
right.
include the
Right, correct. But then too, you'll know, like say when you get here, normally, well, not always. Like when you doing your variable names, you say, okay, I got a string. I might, or you're doing your constant. Oh, I've got something dealing with pi, so I'm dealing with mat functions. So you know what I'm saying? It just should come to you because I'm gonna tell you why you may not want to just automatically load all the libraries. As many libraries as I load here, that's the larger my program is going to be. You understand?
Okay.
So yeah, so the smaller my program, the faster it runs.
Right.
So that's why you want to kind of know sometimes. And like I say, we writing small ones, so it really don't matter now, right? But the smaller it is, the more quicker it'll run. Because there's some other libraries like there's something like called vectors. Vectors work like arrays, and we'll talk about that toward the end. So vector, when you use vectors, you got to load the header file for vectors. There's when I told you something about reading from a data file. When you read from a data file, there's a library called fstream. You have to load so it'll know how to pull in the file and whatever. So so it's just different.
And I imagine those are like rather big header files, or
I don't know. They're not that big. But this is my theory on why C++ was developed in this fashion. Back in the day when C++ first came out, all you had to do was go into C++ and just say include whatever, and it loaded every last compiler. I mean, every last header file. You didn't have to worry about it. So, like I said, I guess the programmers and whatever got smarter. They said, well, if I'm just writing code and I'm using every last library every time I write code, I'm writing these very large programs with code that I really don't need. Right. So they broke it down to say, okay, well, if I'm going to write code, I'm going to only use the ones that I need, which reduce the size of my file, which allows it to run a whole lot quicker. Yeah. So I think that's what I think the idea comes from, to try to have at least number of lines of code to execute as possible.
Plus, just having it modular. Plus, I think just having it modular, like just you can pick and choose just as
You're right. Yeah, this section have these functions. This one use these different functions. Right. Yeah. But like I said, it doesn't make your program cause any errors or nothing. It's just that you load all those libraries. Right. So now we added that. Now I can do something like this. I could do cout, and I could say set precision. All right, and I'll say, I'll do it when I do the output rather than set it now because it's gonna set it for everything. But now I can do cout, and then I have set W. Well, first of all, I'll say left. But remember we said the name, I gave you the alignment, left, which is just the command left, set W, 30, all right? And then I'll do name.
Name,
right. I'll do a name, right? Because this is my header, right? Then we had it's left.
It was a job title.
Right. By default, it'll stay left until I change it to right. All right. So I could say set W again. Right. I got to do it for each column that I'm working with. All right. Otherwise, it's going to default to just, I think, the tab in a 5 or whatever. Set W to 30. All right. I don't need to say left or whatever. It's defaulted. And then I could say job title. All right. I put in a double quote. All right. Then now, I don't really know the specs of it, but I can do set W. I think I had 8 or whatever. I don't know for the other one, like 8. Now this would be for gross pay. All right. So I changed my width, my column width for job title to 8, and then I could set it to I could set it to right or left depending on what I have. All right. Say I'll set it to right. I'm not sure what I had specified. I set it to right, so it's gonna write justified, and now I can output gross pay. No, I'm gonna have more than that, huh? No.
It was like hours, and then.
Oh yeah. Hour. Yeah. Okay. Right. And then what? Same thing. Set W, and I don't need to do the right. All right.
So I had looked up the set W thing and the alignment, and it looked like everyone was putting it per line. So I put it before.
No, not per line. Well, it depends on your output. No. It's not per line. It's per output stream.
I meant like per before every word, I guess, would be like what I'm trying to say. I misinterpreted it. I basically wrote more than what I needed to.
Oh, okay. But even if you did it, because look, see here, I got left right here, right?
Mm-hmm.
And then I got set W and I got name. But in this one, I just got set W, right?
Yeah.
I don't need left if left is going to still be used for this one.
Mm-hmm.
And then this one, I got set W, but you always need to do your set W.
Yeah.
I did a set W 8. Then I did right. But then here, I didn't need to do, I don't need to do a right because by default, if I do this one right and I want this one to be right, it's going to be to the right until I change it.
Gotcha.
And the same thing happens with the set precision. If I do a set precision fix, set precision 1 and fix, any number I print after that gonna have 1 decimal place if it's double or float.
Right.
But if I want to print one number at 1 with 1 decimal place, set precision 1, fixed. But then when I want to print a number with 2 decimal place, before I stream that number, I got to do set precision 2 and fix, and then print the number. And now everything will be set to double space. When I want to go back and print another one with 1 decimal place, I got to do my set precision all over again.
I think in my head, I just kind of treated the alignment stuff just like set W, where it had to be with each one.
Okay, right. Yeah, and like I say, it overkill don't hurt you. Like I said, if you put right, right, then left, it don't matter. It won't hurt you. Yeah, that won't hurt you. Yeah. So this was hours and then what? Wages, huh?
Yeah.
Yeah. All right. And then we had set W, gross pay. I don't know if this was 12, whatever. Okay, let's see, 12. And this would be, all right. Now, normally here, I think I'm gonna do this and do my stream. Long as I do my stream at the beginning, I can't split the word. And I do my stream and
I did my stream at the end of the last line and it still carried over.
Right. Oh, okay, right. And don't worry. And then net the taxes. Then set W. I'll set that one to 8 again. And tax. But notice every time I'm streaming something, I gotta stream it like I'm streaming here and put the cursor on it. What did I do? Wait a minute. All right, I'm streaming name, so I gotta use the stream. I'm streaming my column, streaming job title, streaming column, streaming alignment. So you see, you gotta use those characters to stream everything. All right, you can't just have everything just listed without streaming each one. All right. So taxes and then set W, and I'll change this one to 12 also. And then if I can type. Yeah. And now this was net pay. Right? And then inline. Now, you could, if you wanted to, what did I do? Oh, NL. What you could do now, but you'd have to what? You could copy this. All right, I'm gonna just show you, but you gotta kind of know what you're doing though. You could copy this, and then you can paste this. Oh, if I can paste it. I copied the wrong thing. All right, so I paste this. Now notice what happened. Okay, here it said, this is where I print my column heading. So here is where I can print out what? Name. And I don't have to go and try to add the set W, right? And whatever. This one, I'm printing out the job title. So I could just go here and say title. I erase the actual, stream, and I'm gonna stream out the actual value. So you understand, because I'm on this is the next line beneath it, right? Everybody see what I did though.
Yes, sir.
So that way I could still have my what? My column set for that to the left. I got this set W for this. Oh, something going on here. Got name, title.
I think it just didn't update yet.
Okay. And then here, to the right, and then, but then here, this is where we'll do what? Set precision. Set precision to 1, fixed, right? And then this would be wages. In wages, hours. Hours was 1. Hours, right? And then the next one for wages, I'd have to do what? My set precision all over again, right? Set precision to 2.
Oh, to 2.
Right. You understand? So you see what happened?
Yeah.
Right, yeah. And fixed. And I can't see that. Let me move this. Right. And then set W. My set W. And then this would be what happened?
You forgot to put wages in after
right,
fixed.
Yeah, right here. Oh, I forgot wages?
Yeah. Right
oh, yeah, that's what go there. Yes. Set position 2 and fixed. Yeah, and here. Yeah. And wages. Right. Then we got, rather than gross pay here, what I'll do, I'm gonna take this over. I'll bring this here where I can see what's going on. All right. So then here we got for gross pay, it's supposed to be 2, right? So it's set at 2, but then I'll change this to GP. So I don't need to do a set precision again because what? It's automatically set, right? To 2. All right. And then what? Taxes, same thing. So here, right? And then for the net pay, NP. Now everything, something wrong here. What I did here.
Take the S off of wage.
Oh yeah, wage. Yeah. Okay. Now, so we have this, and what I have for tax, TAX. Yeah. Right. All right. So now when I run this should actually give me my output. So if I build it, to compile, did I use the right one? Yeah. Okay. It says one succeeded, and then when we do the debug and we run it, it should ask us for name, job title, whatever. All right. So name, John Doe, I'm about to say. And then job title. Oh wait, and computer analyst. Okay. Wages. Let's say we use 10 like we did in that one. and we use 80. But we know what? It's float. So I could put a float value or I could put integer value. It's going to convert it when it actually compiles the program. So see here, look, name, and then the name, John Doe, job title, all right? Hours, aligned to the right. Wages, aligned to the right. Gross pay is aligned to the right. Taxes, aligned to the right. And gross net pay, aligned to the right. I don't know how I specified in the assignment, but this is how you would do it. And notice what? 1 decimal place, 2 decimal places, 2 decimal places, 2 decimal places, 2 decimal places. But what? It was inputted with no decimal place, no decimal place. So everybody see that was the idea behind doing that particular project. All right? Any questions?
No
questions? Okay. All right. Like I say, take your time, reach out, do whatever, but like try to at least attempt it. Don't wait till the last minute, because you wait till the last minute, it's very hard to try to rush and program. It's just hard. Now, the next one, all right? This one said what? Really, you're basically doing the same exact thing that you did in that other program, but this time you only had one expression. You were to input each one of the scores, but this time you would have input all of them at what? One time. And this is what I'm looking for. If and I'm gonna just take this out, but we're not gonna run it. I'll take this out, and I'm gonna give you an example of what I was looking for. All right. Well, I'll just type it. I ain't gonna try to take it out. I'll say something like you'd have all your test variables declared, test 1, test 2, test 3. And so you'd have something like, please enter 5 test scores and press, then press enter. All right. So you would have something like that. But what I was looking for here is CN and whatever your variables names, T1, T2, T3, T4, what if I type? T4 and T5. Everybody understand, I wanted you to have one CN statement, and the person was going to type the value, space, type the value, space, type the value, space, type the value, space, type the value, space. When they type the last one, simply hit enter, and it grabs them all at that one time. I didn't want you to do C out, CN, C out, CN, C out, CN, C out, CN. All right? So that was the reasoning behind doing that program. And like I said, you were supposed to calculate the average, and then what? Output the data in the format using the set precision fixed with 1 for all of the test scores, and then set precision fixed 2 for the average, right? Any questions? Any questions? All right.
Sir.
Okay, all right. So the next one, the next program, I think this the last one. All right. Yeah, this is the last one. All right, this program, if you notice here, you had what? A square root, and here it was b squared, which is the power of b raised to the second power. Now, I didn't specifically say use the math functions in here for the square root of b squared. I didn't particularly say use square root. If you had a formula to calculate the square root, cool, all right? But if to do that, to solve this expression, okay, that's b squared plus 4ac. All you had to do was have variables for what? A and b, all right? So you had something like, if I could do something like int a and b, all right? And then I could do a result. All right, A and B result. And in order, and like I say, whatever functionality your program is dealing with, I'd have to do pound include and then CMAT, all right? So that I can use the square and the square root and the power function. So now in here, all right, I said, I don't know if I told you input, but I'm gonna just assign a value. I'll say this is 2, and I'll assign this to equal 3. All right. So all you had to do is something like this, and I'm gonna just do why would you do result? Result is equal to what? If I can type. Result is equal to SQRT, which is the square root function. Now everything that's in the square root, I'll do POW, right? B, comma 2, that's the power function. And then we have what? Plus, and then this would be what? 4 times A times, what I said, C? It had a C in there? Think C. And I'll just create a value for C. All right. C is equal to 2 also. All right. All right. So basically, that's all you had to do. All right. All right. So now, and all you had to do after that was do your see out whatever the results. I'll do. Okay. Okay. All right. See out result. So basically, that's all that program was. I wanted to give you the opportunity to write out an expression using some of the math functions, the square root function and the power function. So what this is going to do, all of this will be inside of the square root, where I'm getting a b raised to the second power. B raised to the second power is what? 9 plus 4 times 2, which is 8, times 2 again, which is 16. So 16 plus what? 8. Is it 8? Yeah. 16, wait, B is 3. 16 plus 9. 16 and 9 is what? 27. 27. And then you get the square root of 27. All right. So what I have? I got an error. C MAT. I got M in mat. All right. C mat. All right. So now when I run it, all right, I'll compile it. All right. And then I'll run it. And I got it as integer. Yeah. So it's going to just give me that whole number. See? So the square root of 27 is just going to give me just the whole number, right? Because the square root of 25 is 5. The next whole number is the square root of 6, which is what? 36, right?
Right.
So that's why it give me just the whole number, because I use integer, right? But if I'd use a double, it'd have been 5 point whatever. All right. So that's what the program did. So class, I'm gonna go through the programs. I might shoot out an email, depending on how y'all did on them. I might open them back up so that y'all can work on them and try to get them right to try to get a better grade. All right. But like I say, make sure you do your header files, because I'm taking 5 points automatically if you don't even upload the header file or either have it called in your program. So do the header file. Get used to doing it. It's gonna help you. Just get used to doing that. And then, like I say, work on getting your logic, down. Write down. You got to do the flow chart and pseudocode. Write it down. What I need to do first. What's next? Write it out on paper. This is what needs to be done. So that you can have a routine. And once you come up with that routine, then you do it all the time when you're writing code, and it'll help you. It'll help you to complete your assignments a lot faster too. Even when you're working on projects, outside of class, it'll help you to understand it, work on it, get the correct data that you need or whatever, and then work on it without having to restart all over. All right? So any questions? Questions?
No, sir.
Huh?
I said no, sir.
Okay, so let's look at the next programs for chapter 4. And then we're going to get in chapter 4. Chapter 4 dealing with if statements and whatnot. All right. Now, we should know how to do what? Output stuff with dollar. Now, the dollar sign here, I just outputted that dollar sign. All right. You can, there's a functionality within C++ that allow you to put a dollar sign. I'm not going to lie. I don't want you to go and try to research that. You could just output this with a certain column width, put your dollar sign at a certain column width, and then I'll put this at the proper column width. So I'm not gonna be too particular with that the dollar sign being aligned, but I want my numbers to be with my decimal place aligned. So you're gonna have a certain column width for this, and then a certain column width for this, and they're gonna be to the right, so that all this lines up here, all this lines up to the left. So if you look at this program, I could read through it, but I'll just kind of generally tell you about it. This program asking you to input the monthly expenses for the maintenance of a car, all right? So you're gonna input loan payment, you're gonna input the insurance, you're gonna ask the user, prompt the user for it. Input the amount of gas for the month, input the amount of oil for the month, input the tire expense for the month, and then the maintenance. Now, you're going to be doing CLCN, CLCN, CLCN. Once you get all that, then I want, this going to be your output. Then I want you to output loan payment this, insurance this, gas this, oil this, tires this, maintenance this. So you're going to grab the data like we did with C and C out, but then you're going to output the data like this. And then what? You're going to come up with a total, okay? You're going to add up all these expenses and come up with a total. Now, that total that you come up with is only going to be a total for 1 month. So here I'm telling you, once you do this, I want you to calculate an estimated yearly total. So how would you simply do that? You'd have to multiply this monthly total by what? To get a yearly expense.
I'm sorry, what was your question?
All right. I'm getting monthly expenses for 6 items pertaining to my vehicle. And this is my monthly cost. How would I get my yearly cost?
Oh, you just add your monthly cost by 12, like you times it by 12.
Right, multiplied by 12, right. So you see what I'm saying? So it's like you got to be able to understand the problem. So you once you get this cost, which is your monthly cost for all these expenses, then you multiply by 12 and get your yearly cost. Now, the program tells you if the yearly cost is greater than, not equal to, if it's greater than $1,000, so if this is greater than 1,000, then you're gonna multiply 10%, or you're gonna add 10% to it, and then and print the percentage, that 10%, and then print out the grand total, which would be the yearly total plus the 10%. If it's not greater, then you're gonna just simply print out 0 and then print out the what? The actual yearly total for the grand total. Everybody understand that?
Yes.
So that's like that if statements for that even and odd. If, and you're gonna have like if yearly total greater than 1,000, multiply yearly total by 10% to get whatever. And then what? Output, add the 10% to grand total. And then if not, you're gonna, you're just exiting out the if statement and printing out the grand total. All right? Because you're gonna print the grand total regardless. But one of them you're gonna print the yearly total of 0. Well, both of them you're gonna do the yearly total either of 0, not 0. The percentage will either be 0 or the 10%. All right, depending on if this is greater than 1,000. All right, but I want you to print out the 10% if it's greater or 0 if it's not. Okay, so that's that program. The next, and like I want my dollar, I want my 2 decimal places. I want my 2 decimal places. Now, looking at this program. Now, based on the other program, some of you all did the program but didn't do it the way I asked. Give you an example. If you notice here, I have 2 values in inches. What some people did in the previous program, they allow. They say please enter a length. Okay. Well, no, please enter feet. I put in a feet. Please enter inches. Put in inches. Please enter feet for the second one. Put in the feet. Please enter inches. But that's not what I wanted, because what happened is what I did in the program, I put in 1 foot, then I put in 24 inches. Then for the second one, I put 1 foot, and then I put 24 inches. So what happened? It added the feet, but then the inches was what, 48. So they never converted the inches to feet to say, oh, this is what, 6 feet, 0 inches. So the thing is, you're gonna input 2 different lengths, all right, whatever they may be. Once you input them, I want you to calculate the total, all right, of those inches. Then take the total inches and convert that to inches, feet and inches. Okay? So make sure you do it the way it's asking you to do it. So you're going to, and this is just the output. You're going to have something like see out, please in a first length, and you put it in. And please, and see out, please in a second length, you put it in. Then you're going to calculate the sum of them. And then you're going to do however you do it. Some people tried to use a multiplication expression to get inches and feet, and it didn't come out quite so, because it don't round up or whatever. So I took points off of that. But if you use that modulus, a formula, you can get the right answer. All right. So now, and you got to be able to check your answer before you turn it in. So now, once you calculate the inches and feet, now it tells you, we go back to this, it says, after outputting the distance in feet and inches, if the distance is greater than 3 feet, so looking at this is greater than 3 feet, so it says convert the distance to meters, all right? Displaying the remaining distance in centimeters. So all of a sudden, if this is greater than 3 feet, then I'm gonna take this 9 feet 3 inches, and like I say, 9 feet 3 inches is 112 inches. So I'm gonna take 112 inches and convert it to meters, and the remaining of that I'm gonna convert it to centimeters. Everybody got that? Cause what? How'd a meter go? A meter is a little over a yard, like a yardstick. So what happens is you're gonna come out with, like, say 2 meters and like say if you come out with 2.5 meters. What is 0.5 meters? You're gonna have to take that 0.5 meters and convert to centimeters. All right. So that's what I'm saying. So when you get this distance, you're gonna convert it, and basically you're kind of doing it somewhat the same way, because you gotta take this and convert it into meters. Take these inches, convert it into meters. So that means what? If you have something left over, it won't be a whole meter. It'll be less than a meter, and you take that portion and find the centimeter part. So now what? If I don't know how to convert that, I need to go online, look it up, look up the formula, and then what? Put it in my program. All right. But if it's not greater, if this value is the feet is not greater than 3 feet, and like I say, I want you to calculate the inches in miles. Okay, how many inches is that in a mile, or whatever that distance is in a mile? So, and now you're gonna come up with point whatever, depending. Because what? 2 feet is how many inches? Well, how would I say it? 2 feet is equal to how many miles? Is equal to how many miles? And so that would be point whatever miles. All right. And like I said, you can calculate that. 1 inch is equal to how many miles? 0.0000 whatever miles. All right. So you're gonna be dealing with some small numbers, but it can be done. Everybody understand that?
I have a question.
Yes, sir.
If it's not greater than 3 feet output, it should look like the following. Is this saying that should be the only thing outputted, or should
right? Because what? Because you shouldn't do you shouldn't do the metric part.
Okay.
Right. Only if it's less than. If
Okay,
it's
so
greater than, right, you're doing this. If it's less than, you're doing this.
okay, so it's between it's if blah 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 metric
You're
else.
doing a metric conversion and output.
Okay, I wasn't sure if
Otherwise,
you were excluding the top part above the metric.
that you're gonna calculate that regardless, because this is gonna determine whether you do this or this.
Yeah.
Right. Yeah. And like I say, some students get this confused. What they'll do is they'll do see out in a lint, and you type 90 and they say, well, I done put it in. I don't have to do the sum or whatever because I inputted that. No, the input part you don't really see. You got what I'm saying? This is the outputted part once it's inputted.
Yeah.
Right. Okay. Yeah. Because some students get that confused. They say, well, I done inputted it already, so why should I have to do this? Well, this is the output though.
Yeah.
So you got to capture the data and then output it. Right. Okay. So that's that one. And then they got one more. Now this one is a little bit different. This one dealing with nested ifs. Nested ifs. You got to read through it, understand it. Now look at this. It says write a program that will allow a user to enter a number. And we got to go over that in the notes. A number between 10 and 30. Now it says between. Is 10 between 10 and 30?
No.
Right. So it has to be greater than 30 and what? Greater than 10 and less than 30. Everybody understand that?
Yes, sir.
Right. So like I said, you got to kind of understand your math. So let's look at that. What I'll do, I'll pull this up. Okay. And we'll go through the information. Well, I'll just leave all this up let's see. I'll just say, okay. I'll say,
I assume you would do like an if, or would it be a for statement with a range?
I know. All it is nested ifs.
Okay.
Watch. So it says what? See out, enter number. All right. Okay. CN. One. All right. So now it says what? Allow a user to input a number between what? 10 and 30. So now look. So if, okay, num1 is greater than 10. Now, we didn't get to it yet, but we're going to get to it. Greater than 10. And now we can, and then we got to use and, and I'll show you, I'm gonna go over that once I do this. And num1, I got to use num1 on both sides. I can't just say num1 greater than 10 and less than 30. I got to say num1 greater than 10 and num1 less than 30. All right? So now what that do? That put me in a pocket, right? Any number 11, 12, 13, 14, 15, 16, 17, all the way to 29 would be valid.
Wouldn't that be the range I was talking about, though?
Right, but you said something about a loop, right?
Well, I got confused on if it was the for that did the range, or if it was the if statement, because that was from last semester.
Well, you could somewhat use an if statement, but that's looping. That's continuously looping. Well, not continuously, right? But why? Now, what you're gonna do here is put your brackets. Now, with an if statement, you can't just have, I'm going to do this, or you can have it to where I'm going to do this, else I'm going to do something else. Okay? Everybody agree with that? I can just have an if statement says, if test score is greater than 90, give them 10-point bonus, right? And nothing else. Anybody else make an 8 or whatever, I'm not even considering them. I'm not even giving them anything, right? So I don't need a else. But what I said here, in this program, I said if is greater than or equal to well, if it's between 10 and 30, I want to do something, correct?
Yes.
But if it's not, so that means what? I got another condition. So I'm going to have to do an else.
And that's where you would do the loop.
Right. No, it's still not a loop.
No? You don't want them to, well, okay. My idea is that you would have them enter the number, and if the number was not the number, you would loop it to where it would require them to input another number until they.
No,
that's chapter 5.
We ain't got to that.
Okay.
Yeah, we ain't got to that chapter yet. We ain't got to that chapter yet, though. This one's just gonna deal with that logic of ifs and nested ifs. So let's look at like what it says. All right, it says if the number is between 10 and 30, right? If the number is inside of the range, all right, output what? If it's outside the range, output what? Invalid number has been entered. So look, this is the true part. If it's true, I got to do something. But if it's outside the range, I got to output what? See out and invalid number. All right. So, so you see what happened here? Now, if it's valid, all right, if a valid number has been entered, that means it's between what? 10 and 30, right? If a valid number has been entered, allow the user to enter a code of A, B, or C. So now what? Inside this true part, the valid part, now I need another what? If, right? So now what? I need to go back here though. I need to input that and do a C out, enter code, all right? So this will be, I input a number, and now I'm inputting a code, CN, and I'll say C1, all right? So I'll go up here and say char C1. All right, so now, I'm I ask the user to input a number and ask the user to input a code. So now I'm gonna do if what? C1, right, is equal to, right, A, not single quote. Because remember it's char, right?
Yeah.
But then here, it can't equal to A, B, and C all at the same time, correct?
Yes, sir.
So I have to use the OR command. So if C1 is equal to A, or C1, C1 is equal to B, or in the or, that's the pipe symbol. That's the pipe symbol. Or C1 is equal, and equal is the double equal. And we got to go over that. C. Now, and so I'm going to change this one to the pipe symbol. Now, the thing is,
would have the letters of or worked?
It'll work too, but in some cases, yeah, in most cases, it should work. All right. All right. If C1, what did I have here? I did something wrong. What I got? C1, that's C1. Oh, no. No, what did I do wrong here? CN1, if. C1 is a character. Oh, I got some. Oh, semicolon. All right. So now, the thing is, I took that one off.
Do you need another equal sign for the B?
Yeah, because then too, that still don't get what shouldn't give me an error. Yeah, okay. Because see, with that single, and we got to go over that. That single equal assigns, the double equal compares. But we're gonna go over that now. So the first one. If you and look, you got to understand these ifs. This if right here, if number is greater than 10 and less than 30. Okay, let me ask you this. Is 12 greater than 10?
Yes.
Is 12 less than 30?
Yes.
Yes.
So both sides are true, correct?
Yes,
Correct.
sir.
So 12 would be a valid number. Now let's go to the next one, and I'm gonna get to what I mean. It says if C1 is equal to A, or C1 equal to B, or C1 equal to C. Now what is that saying? It could be what? An A, or a B, or a C, and it could be valid, right?
Yes, sir.
All right. So if I put in D, what did happen? It's what?
It's invalid.
Invalid. If I put in A, that
It's
expression
valid.
is true, right? If I put in C, that expression is what? True.
True.
Because R said one or the other. If I asked you, say you took 3 tests, okay? If I say if you made a 20 on test A or test B or test C, you get exempt. All of them don't have to have that score, just one, right?
Yes,
So
sir.
that's how the R works. But if I said and, if you got a 90 on test 1 and test 2 and test 3, you exempt. That means what? All of them have to have what? That score. Correct?
Yes, sir.
All right. So now I'm gonna show you where I'm getting that from. Let's go. I'm gonna click on this page here. This is our web page. If you click down here on this Boolean truth table, what happens here? This is how you can equate your if expressions. Notice we had what? If what? What that was? Num1 was greater than 10, right? And then we had num1 less than 30. So the greater than 10 would be the P side, and the num less than 30 would be the Q side. So if the P side is true and the Q side is true, then that expression will yield to be true. See, P and Q yields true. If any one of the sides are false, then it automatically fails. Because if I said, if I put in the number 35, is 35 greater than 10?
No.
Is 35 greater than 10?
I mean, yes, it is.
Yes, but it's 35 less than 30.
No.
Right, so it won't fall in that what? That range. You got what I'm saying?
Yes,
so
sir.
that will make it false. So if any one of the sides is false, that will make it false with an and. But then when we go to the R part, we got if true or true, it doesn't matter which side, any side true is going to make that expression true, right? So true or false yields true, false or true yields true, but false of any of all of them with R going to yield false. All right. So what? I'm go back to the program. So what I'm doing. If this side is false, I got out the program. If this side num greater than 10 is false and num less than this is false, if both of them is false, it's automatically false. If one of them is false with and, automatically false. With and, they both have to be true to fall into here. All right? But look at this one. You got R. If this is true and this is false, it's still true. So if it's A, as true as false, but then you go take the true part, true against this side, false, true or false, still make it true. All right? So now, what I'm gonna do, I'm gonna put my curly braces here. So notice what's happening. I'm grouping everything. Every time I put my if logic, I'm grouping it, right? So I can keep control of what's going on. So if I put a number that's not valid here, and it checks it here, it's gonna say, oh, invalid number has been entered. So I'm gonna run it. Let me run this, and it ain't gonna go into all this other stuff. I'm gonna just put an invalid number. So I'm gonna build it, and let's see. My debug. Oh, it's not. Oh, yeah, debug. And click here. All right. So now it should come up. All right, enter a number. Somebody give me a number.
3.
All right, 3. Is 3 greater than 10?
No.
So automatically with that and, I got two sides. If any one of the sides is false, it's automatically what?
False.
So I should get what? An invalid entry, right? But
Yes,
because
sir.
3 is less than 30, but it's not greater than 10. Well, no, I got to input a code because I didn't get to the logic till I put a code. I'll just put the letter A. But look, an invalid number has been entered. You see that? So it automatically kick out and say an invalid number. So let's run it again. All right. All right. Run it again. Give me a valid number.
25.
All right. 25 is greater than 10, and 25 is less than 30. Correct?
Correct.
So this time what it's going to do, it's going to try to go in and compare. Well, I got to type the letter. I'm going to type the letter A. I'm not going to get any output because I don't have nothing in that if logic for A, B, or C, right? So
Right.
it's just not going to give me that error. So I hit enter and see. So you understand what happened. It went inside the if that logic and it went inside of here and I don't have anything in here, all right? So let's go back to the program, to the instructions, and we go back here. All right. So now it says, all right, A, B, or C. All right. It says if a invalid code is entered, output an invalid code has been entered. So what? If it's valid, I'm going to do something. But now, if it's invalid, I need an else. And then my curly bracket. So you see what I'm doing here? Why get this else? Why get this error on this else? That's right. Yeah, let's see. That's right. What's going on? Oh, I put a semicolon here. Wow. That's another thing, class. On an if, you don't put a semicolon at the end of an if. You're looking for trouble. All right. So now, I have if A, B, or C, then what? It's true. If it's not A, B, or C, I said what? An invalid code has been entered. So I can go in here and what? And I can say C out. All right. All right. So now, if I run the program again, right. So I'm gonna put in 25, and now I'm gonna put in an invalid code. An invalid code would be what?
Any letter like D, I guess.
D, correct. Anything other than A, B, or capital A, B, or C. And hit enter. And look, an invalid code has been entered. See? Now it didn't print an invalid code has been entered, an invalid number has been entered. Only what? An invalid code has been entered. All right? So you see what I'm saying? Some tutor, they write their logic to where it's not right and it's gonna print out this and this. Okay? Now, I want to show you something. So look at this. When I put in a number in a code, it asks if that number is valid. If it's valid, it falls in between here. You got what I'm saying? This is the true logic. The true logic is a nested if. Okay? Then when it gets in here, if this is true, it only does this. It won't go down and do this else here. It only gonna do this or this and then kick out. All right? So now, if you look back at it, it says, where I'm at, okay. If a valid code has been entered, allow the user in the, okay. If a valid code is entered, output, that's invalid, okay. Then info, which we did. Okay, using the value, and some students get this wrong because the examples show something else. Using 28.82, all right? If the number that a person enter is between 10 and 20, all right? If it's between 10 and 20 and the code is equal to A, add 5 to the decimal value 2.2. All right. So 2.2 plus 28.82. Wait, let's see. Yeah. Right. No, add 5. 28.82 plus 5 gonna give you what? 32.82. But this is just an example of any number. But add 5 added to it. You're gonna add 5 to this number. If it's B on the valid part and the number is between 19 and 30, you're gonna add I think 10. And if it's C and it's between the number between 19 and 30, you're gonna add 100. Okay. And then the thing is, if it's neither one, you're gonna write invalid criteria. So what happens is, so if it's A and B, if it's equal A, B, or C, then now in here you got to do some things. Now you got to ask what? If num1 is what? If num1 is greater than 10, well, we know it's greater than 10 because we're in here. But you could say if num1 is greater than 10, and we did that one, and well, not greater than 10, it's less than, because we know it's greater. If it's less than what? 20. Right. So if it's less than 20, but and, right, C1 is equal to A. You got what I'm saying? Now we're going to do what here? Add what? And we could say num
5 to 28.8.
Right, correct.
I think the confusing part about that is that
I have the example as 2.2, right?
Yeah, and I thought to myself, well, that would be the number that they entered, but it would already be wrong because it's not between 10 and 20. I see that that's not what you meant, though.
Right, correct. That's right. Right. So now, so here, I'd have to create. I'll create something called total. Well, I can use num3, I'll say here and num3, and I just like to put them in parentheses though. I'll just say num3 is equal to 28.82 plus 5. All right. So now, that's gonna add that, right? So it's gonna add that, and like I say, when you want to output it, you just output it what? Outside of all the loops. I mean, not loop, if. So out here, I could do the C out. Well, no, you can't do it in there. You got to do it inside, because if you do it outside, you get an invalid one, and they're gonna still try to print a value. All right. So you do that, and then you'll do a C out num3. All right. But that would be the number. But then what? I got to do else if, because what? Now I need to check, right? Because if it's not A, right? If this is not true, I need to check the next value, correct? Right. For B, and the value for B. So I need to check to see if else if
num1 is
greater than 19, right? And code is what?
Well, you still have to do if B. num1 is less than 30, right? Or I guess not.
Because we don't. You see what I'm saying? We don't fail inside that loop. Yeah. So now we're just checking that range of greater. Ashley. Gotta get my daughter to go pick up my son. Ashley! This girl, man.
Give her a ring. You know?
No,
I'll
tell you, man.
I'll tell
you. Man, they'll pick up on that.
Right?
Man, I don't understand that. Man.
You know, it is only 11:20. She might still be asleep.
Oh, she need to get up. Man. Because I still need to go over the chapter. Because what we... Hey, go pick up Jade. Oh, where you at? On who?
Corsi.
Yeah, go pick up.
Yeah.
Go pick up Jade. All right, bye. Man, that saved me. Now we could have class. We have class all day now. But
All right.
let's see. All right. So we don't need to check the less than because all that fell in here. Like if it's greater than 10 and less than 30. So here now we could check to see if num1, if I type, num1 is greater than 19, right? Why? Hold up, Club. Hello? People be calling by craziness. Okay, if it's greater than 19 and, right? And C1 is equal to, and remember the equal to is double equal B, right? Then now what we want to do, and what I'll do, I'll just copy this. But when you copy and stuff, man, you got to make sure you make the proper changes. I'll paste that down. So I'll keep that same information, but this time num3 is equal to that plus 10, and then num3, I'll put it in and finish. Then I have to do the same thing for C, but let's run it. Let's see what happens, right? So let's run it and see if we're on the right track. Okay, so I'll compile. Oh, what did I do? I don't want that. All right, let's compile it. Okay, and let's debug it. Okay, all right. So now, give me a valid number.
Do 20.
20? All right,
Yeah.
so I did 20. So if I do letter A, what's gonna happen?
It will it run the
Well, let's look at the
it will
code.
run the first one.
Well, yeah, see, okay, if it's this, it's gonna fall in here. If it's A, B, or C, it's gonna fall in here. If number is less than this and equal to A, no, because what? It's not less than 20.
Oh,
and then,
right.
So it won't do anything. It won't do it because we don't have nothing set for it. You see what I'm saying?
Yeah.
Right, so it won't do anything. But if we do 20 in B, what's gonna happen?
It'll do the second. Yeah.
Right, correct. So if I do 20, and let's do A right quick. See, nothing happened, right? So let's do 20 in B. Do 20 in B. Say 20, and we do B. See? It added what? It's got 30.
The 10.
Oh, it must be. I must have made it integer, huh?
Yeah, you did. You just used the one you already had.
Right. So you see what happened? It gave me that value there. So that's the thing. But now you got to keep going because if it's none of, we know it should work for any one of them. But no, invalid criteria. So let's finish it, and you should be able to write it. Hopefully, I do enough of it where you can get started with it. And so let's do the last one. Let's do the other else if, and then what? Num1 is greater than 19, right? And C1 is what? Equals C, right?
Yep.
Now, and we want to basically do the same thing of this. So I'll just grab all of this. Yeah. Well, I got that error right there. Okay, wait. I need all of this. All right. Copy this. I'll go here and put this here. All right. And I think this one is 100.
Yep.
Okay. And that's 100. So now, so that'll print that. But then what? If it's none of those, I'm going to output what? Then I'll just do a else, not a else if, because you don't want to do an else if at the end. I done check for this, I done check for this, I done check for this with an else if this, and then the last else should be just else, invalid, whatever. You got what I'm saying? Because if you do an else if, you got to do a true part and a false part. So else, see out, and I think it said invalid entry or whatever it said. I forgot what I had, but in line. Now, so let's run it, and we're gonna put in that 20 and A, right? Remember that?
Mm-hmm.
So let's run it now. Debug it, and then we put 20 and the letter A. Because remember, A should only be between what? Between 10 and 20. See, invalid entry. You got me?
Yes, sir.
All right. And then now I could put B. I could put B. Let me put the B. I could put the B. And when I put B and I could put 10, not 10, B in like 11 or 12. So let's run it again. Debug. All right. Did I should be there?
Did you answer that phone
Oh,
call?
I hit the wrong thing. Let me stop that. Yeah. Yeah, so I'm gonna do that. All right. So I'm gonna do that. Come on, run. I think I clicked the right button. I thought I did. Come on. That's my computer. It's saved. I'm gonna close it out and come back in.
Well, that's if you can do that.
Right. I don't know what's going on. Oh, here we go. I don't know what. No. What's going on?
Is that the one to the right over there on your taskbar?
Where at?
At the bottom right of your applications. Is that it?
Yeah, but it's nothing on the screen. Like it's still running. I'm gonna do it again. I'm gonna see.
You didn't
Might
close
be
it
my
properly
memory.
last time, I think.
Okay, there we go. It was trying to use that one. All right.
Yeah.
So let's try what said what we said B. We tried B, not yet. We tried 12, right?
Yep.
And then let's try B. So what? That's invalid because what? B should be above 20, but what 20 and between 20 and 30. And when I hit enter, it should say invalid entry. So you understand? So if you take your time and like you say, you gotta write it, but you gotta understand how the if logic goes.
Yeah.
And like you say, based upon input your data, if this, and then I can say, if I got an if, then what goes in the true part? What goes in, if I have a false part, what goes in the false part? Inside the true part, if I have another level of ifs, I gotta, put that in there. And that's why and we didn't talk about it much. Programming style, man, it's crucial when you start dealing with coding if you have all of your ifs are lined up evenly, it makes it very hard to know exactly where and what's going on and what level you're at and where to make changes. Because
right.
you just don't know where you are and you start guessing. All right. So let's go to the chapter. All right. Let's look at the chapter because that was the last program, right?
I believe so.
Okay. All right. And what I could do, I could try to post this lesson, the Zoom lesson.
Mm-hmm.
And you can go in and look at the code and try to fix it. Because you got, like I say, you can try to copy it, but you got to know what you're doing. But like I say, try to work it out, look at that as a guide and try to figure out and go back. But we're going to go over the chapter right now. So some of the stuff you see, you're going to say, oh, okay. Now I see. Oh, I understand why. All right. So any questions? We're gonna go to the chapter, but anybody have any questions?
No, sir, I'm good.
No, sir.
All right. So let's look at the chapter. So in this chapter, it talks about going to talk about relational operators. A relational operator is an operator that pretty much compares something. You got greater than or equal to, less than or equal to, not equal to. All right. So what are those operators? Let's see what they are. And like I said, I'm kind of just skimming through the chapter because this just talk about, greater than, whatever. And you should understand what greater than is, greater than or less than. But let's look at those actual symbols. So greater than, pointing to the right, less than, pointing to the left. But now look at this. Greater than or equal to, okay? Greater than, and this is how it's written. It's not equal to in the greater than. It's greater than or equal to. Like I say, some students, they get caught up and mess that up. Then look, less than or equal to. So everybody see how those symbols are written. Now, the equal, or when you compare it, this is the equal. Now, let me give you an example. Let's go back to Visual Studio. Now, I'm going to close this out. Now, when I say close it out, but I'm going to take all this out, and I'm going to show you something. What I mean by that equal sign can get you caught up. So, and I'll just use number. All right. So I'll say int number, and I'm not going to input it. I'll give it a value. Equal, say 100. So we know that num1 is equal to 100, right? So let's write some if logic. All right. If num1 is equal to 100, all right, then we're going to see out, okay, and we just say great job. No. I'll say great job. Okay. All right. So we'll say great job. All right. So now, so we know it's equal to 100, right? So if I run this, it should say what? Great job, correct? Let me close this up. Okay. So we should get what? Great job. Right? Great job, correct? So everybody see that. Now watch this. Watch when I do this. And believe me, it will happen to you. What this says, and we just reading it out, we can say if num1 equal 100, right? What the output gonna be for this? If I have my code this way. Anybody, what you think the output's gonna be?
Huh? Oh, it'll be great job.
All right, it'll be great job. Now watch, I'm gonna run it. I'm gonna say great job. All right, now this is what I'm gonna do. I'm gonna do this. What did I do? I changed num1 to equal to what? 101, right?
Yep.
What you think the output gonna be now?
It's probably still gonna say great job.
Because
you just changed its value to 100, like in the if statement.
Correct.
Yeah.
That's right. That single equal assigns the value. It's not comparing it, it's assigning it. You got it in an if format, but it's saying if, but then assign num100. And that's true. So it's going to do the true part. So you're going to get the same result. So like I say, no matter what that value is prior to that if statement, if I have one equal sign, it's going to automatically make it true. You got me? I can make it whatever. I can make it 1,000,000 or whatever. It's going to still be true because this is the value I'm giving it, but here I'm reassigning it the value of 100, which makes this expression true.
Right.
Everybody understand that? So when you use an if, make sure you do what? The double equal so that you are comparing num1's value, which is this, to 100, which is this. All right? Because you're going to make that mistake. And, man, that could give you headaches. All right? Now, and then the not equal. All right? And look at the not. Exclamation point equal. All right? That's all it is. Not equal. So all you have to do is like this and put shift over the 1, not equal. So num1 not equal 100. That would make this what? True. 105556551 is not equal to that. That's true. And I tell people a lot of times in the South, we talk a lot with double negatives. And we understand what each other is saying. But when you're dealing with the computer, 2 negatives make a what? A positive. So you got to be able to adjust when you start writing code and whatnot as to your culture and whatever, because you can't. It was confusing for me. It still is at times because I know I talk a lot with double negative, but when you're writing code, you're gonna have to kind of break that mold because it's gonna give you some headaches. All right. Okay. So now, so those are the symbols. And like I say, you're always comparing one thing, either a variable to another variable, a variable to a constant, or a variable to another number or something. And basically x greater than y, x less than y, x not equal to y. All right. So those are some of the things. And look, it's just showing you this and how you pronounce it. X greater than y, x less than y, x greater than or equal to y, x less than or equal to y, x comparing if x is equal to y, and checking to see if x is not equal to y. So that's how it goes, all right? And like I say, that double equal, man, you gotta be aware of that. Now, the thing is, when you're working with if statements, even loops, and who asked about them loops? That was
me, Mr. McDowell.
Mr. McDowell. When you're working with loops, really what happens here, like when it checks this, you really get a value of either 0 or 1. Because 1 is true and 0 is false.
Right.
All right. So that's what's actually is happening when you write an if statement or whatnot, and you're having a while statement and you hit that while statement while whatever is not equal to whatever. It checks it. If it's true, it's gonna fall into the loop or the true part of an if and continue. So that's basically what is happening. All right. And in the chapter, we're gonna see how those results, how it does that, and you get either 1 or 0. All right. So we know that this is comparing to see if a value of A is equal to 4, comparing to see if A is equal to 2. And this just give you that little warning about the single equal sign and the double equal. Make sure you understand the difference in the two and you use them appropriately. All right? And like I say, this just showing you the format of how you can use those relational operators. All right? Greater than or equal to, less than or equal to, not equal to. All right. So it's just showing you the syntax of how to use them. All right. So now it gives you this, and you could go over this. If x is 10 and y is 7, this would be false. 10 is not less than y, because this say x less than y, 10 less than 7. That's false. And so you could go through the y not equal to x. That's true, right? 7 is not equal to 10. So those things, that's how it works. All right. Normally, okay, look at this. True, false. All right, a Boolean. So what happened is, like I say, when you do an expression, it actually generates a 1 or 0. But you can have Boolean expressions. We never use them, but you can. Like we have string, we have int, float. You can have a bool variable. All right, that bool variable can only hold a value of 0 or 1. All right, and if you look at this program, look what happened here. They set this bool value of true val and false val. But look what happens. X is equal to 5, y is equal to 10. look at this expression, x less than y. Is that true or false? Is 5 less than 10?
Yes.
That's
Yes.
true, right? So what? It assigned 1 to true value. You got what I'm saying? Is y equal x? 10 is not equal to 5. That's false. So what? It assigns 0 to false value. And they outputted false value, and they got true value, they got 1, false value, they got 0. Right? So that's how you can see how the actual expressions, when you're dealing with it in an if or a while, it actually returns a 0 or 1. Right? And we're going to see later on is it will perform a true logic whether something is anything other than 0. 0 is false. Anything other than 0 is true. Right? But we'll see that later on in the thing. All right. So here, now you got what? Z is equal to x less than y. What is going to return? It's going to return a bool value of what? 0 or 1. Right? It's not going to return x times y, x plus y, whatever. It's going to return the relational value. And it comparing x less than y, which is going to give you either 1 or a 0. Right? When you output x greater than y, you outputting that relational value. All right? If what is x? X is 10, y is 7. X greater than y, it will when it see out x greater than y, it's gonna output a 1. Right? Let's look at it because like I say, sometimes seeing is believing. All right. So we did this program where we did num not equal 100. Now this would be false, so it won't print anything, correct? Because what? This number is not equal to 100. Right? Well, no, that'll be true. My fault. Wow. That'll be true. So if I go down here and I'll say C out, and I'll do, and then I'll do this, if I can type, and I'll do num1 not equal num, all right? It should give me that relational value. So if it print out great job, it should print out here what? Num1. What I got? Num1.
You don't have a num.
Yeah, that should be 100. Yeah. All right. So now, if it print great job, this should print out 1, right? So I'm going to run it. See? Great job. It print 1. Now, if I go back and I take this not equal off and put equal, it should do what? Print the 0, but print nothing before that. Oh, I can't see it.
Wouldn't it still print 1? Because you didn't change its value. Because in your bottom line, it says num1 is not equal to 100.
Oh,
Wouldn't
yeah, I
that be
didn't
true?
change it here. Yeah, I didn't change. No, I didn't change the expression. Yeah, you're right. I didn't change the expression to equal the expression in the if. Yeah. So now when I run it, you're right. When I run it now, it should give me nothing but then the 0. See? Right. Okay. So it actually gives you a bool value. All right. Okay. So now, okay, here well, they talks about whether or not this is true or not. So you can actually do those in the chapter quiz. The if statement. Now, the if statement. With the if statement, I can ask you a question like, and normally I use this one, and I do it with all my classes. If I send a student to the Coke machine, and I'll say, okay, go to the Coke machine, and if there's a Coke, bring me a Coke. Now, that if logic says what? If there's a Coke, do what? Get a Coke. What about if there's no Coke? I didn't give any instructions on that, right? So that's the simple if statement. The simple if statement says, if this, do this, and then continue with the program. Don't worry about else, whatever. If it's true, do this, and then continue. All right? And like I said, that would be something like if you wanted to just give people who made a 90 and above 5-point bonus. You would say if test score is greater than or equal to 90, add 5 to test score, and then just continue. So when you hit a person and say if test score and they made a 70, if test score 70 is greater than 90, no, it's not. You won't do anything. Just continue with the program. All right. But with an if statement, you could have something like, okay, use the Coke machine reference. If there's a Coke, buy me a Coke. Else, buy me a Sprite. So now I got what? 2 options. But the first priority is what? To buy the what?
The Coke.
Buy the Coke. Once you buy the Coke, you're finished. And then continue on. Now, if there's no Coke, but then you default to the what? The else logic and what? Buy the Sprite. So that's how the if logic, the second part works. One of them is just have an if and do this, and that's that. Another one, you have an if, and you may have 2 parts. Do this, else do that. Now, in reference to that one, I could say, okay, if a student made a 90 or better on a test, give them 10-point bonus. Else, give them 2 points. So now what? Everybody gonna get points, what? Based upon the test score. What? If it's greater than whatever, you're gonna get this. Else, you're gonna get the 2. You see what I'm saying? So it depends on the logic that you have in your program. All right? With the if. And we basically, in our lives, we use if every day. Because what? Oh, if I do this, I can't do that. Or if I do this, then I'm gonna do that. And if that is not that, I'm gonna do that. So we use that logic every day, in our daily lives. All right. So this just showing what? If it's cold outside, get a coat and then continue on. Basically the same thing I did with the Coke machine. All right. But what? I could have multiple statements. I don't just have to have one. But class, I'm gonna show you something. I'm gonna go back to this programming logic. Now, what I can do, class, being that I have only one, I'm gonna make this a little bit bigger. Oh, can I add? All right, I'm gonna make this a little bit bigger where you could see, because I know, okay. All right, so looking at this logic, I always put the curly braces, whether I have one statement or 50 or whatever in that if. But if you only have one statement that you need to execute for that if, you don't need the curly braces, all right? But I tell students what happens is you can get confused sometimes when you start adding code, adding lines of code. So say, for instance, for this if logic, if I wanted to output great job, add a number to whatever, and then print out great job and do another command. If I wanted to do all that with that if statement, I have to enclose them in a body of curly braces. If I don't, it's going to just do the first one and continue on the other one. And then if it's false, it's going to just skip the first one and continue with all the others. So let's look at this. This is correct. If I only have one statement to execute, but what I'll do, I'll do it like this first. So if num1 is equal to 100, and I'll change it to 100. I'll do the not. I'll change this. If it's not equal to 100, all right, and I'll just change this sort of match. All right. So if it's not equal to 100, I want to print great job, and then it's going to print this last statement because it's what? It's not a part of the if, right? If logic, the very next statement is a part of that if. You don't need curly braces. I just tell students to use them to be comfortable because when you start modifying it, you don't want to forget because it can change your logic. So if I run this, it's going to print great job, and then it's going to print 1. What happened? What happened? What's going on here? Oh, let me see. I must be having some issues with. Okay, all right. Print great job, print 1. Now, say I wanted to add 1 to num1. All right. So I'll say num1. Oh, if I can tell you. num1 plus plus. Well, we didn't do that. I'll just do it like this. Num1 is equal to num1 plus 1. All right, do it that way. Yeah. All right, so I'm adding 1 to num1, right? Right, class? Now, what I'm going to do, I'm going to do a cout. And I'm going to say num1. And then I'll do num1.
It's just going to do those regardless.
Right. And see, that's what I'm trying to get a lot of the students to see. All right. So what's going to happen is, by default, it's going to do what statement?
It's going to do the num1 equals
Plus.
num1 plus 1.
Right. And then it's going to say what? Continue on with the program, correct?
Yeah.
Right. So let's run it. So debug it. So it's going to add the 1 to it. It's going to increment this, and then it's going to print out 1. Now, okay. So everybody see this, because what I'm going to do, that should be a /T. But what I'm going to do now is I'm going to change something. What I'm going to do is I'm going to change this logic here. I'm going to change this back to equal. Okay? Now what my output is going to be?
It's going to be the just the num1 equals and then just 1 increment lower. And then the great job as well.
Right, because what it's going to say, okay, this is my number for num1. If num1 is equal to 100, it's not. So what? It only going to pay attention to what? This statement, because it's going to ignore this statement because this one statement is associated with that if. And then what? Continue with the program. So it's going to output num1, which is going to output this value, and then it's going to output great job and output
the way
0.
I think about it that helps me is that even though they're on 2 separate lines, they're the exact same statement because of the semicolon. You could put those on the exact same line, but it's still one statement.
You talking about like here?
The if, yeah.
But it's still gonna print out that cout though, right?
Oh yeah. But I'm just saying to help me figure out like how my if statement is gonna work. I put the brackets regardless.
And now I said it helps, right. Yeah. Now, because like I said, let's do the brackets now and see what happens. Because now we want to say, okay, we want to do this, and then we want to do this because what? This is the body. I want to what? If num1 is equal, I'll say not. No, not. Do the not. Why? Even if I do the equal, all right? Do the equal. If it's equal, no, it won't do this. It's just gonna output what?
It won't even do that.
0. It's gonna do this bottom one, right?
Yeah.
Right. So when I run it this time, let's get the output and look at it. Oh, well, man. Okay. See here? Because what? It says what? If num1 is equal to 100, it's not. So it's going to skip all of this. Remember last time it skipped this, but it printed num1, which was this value here, and great job, and then it still printed out the 0. So, like I say, you don't have to, but I would recommend you put the curly braces so that whenever you have to go back and add data or add lines, you know where those lines of code go, rather than forgetting to put the curly brace, and then your program logic is just, wow, it just, you just don't know where. And I'm gonna tell you, if you have 100 lines, well, you can say less than that, but 100 lines, 200 lines, 300 lines of code, and you got curly braces that's off in somewhere in your program, you could be the programmer. It's sometimes very, very hard to find that mistake. So I just say you put them, and it'll help you. All right, but you don't have to. Programming style. Whatever style you like. Because some people put a lot of stuff all on the same line. Sometimes that's a problem, because if I have all these lines of code on one line, if I get an error on one of those statements, all of it gonna be saying that it's on that one line.
Right.
You understand? The program gonna run, but it's just that when I say run, you run the program, it's gonna say, okay, error on line 16. And you're looking at 16, you gotta look at this, and this. So it just makes it a little more difficult. Is it right or wrong? No, it's not. But it'll help you, to better debug your program. All right? Okay. So let's go back to the chapter. All right. So, like I say, your expression, and you can have one statement. You don't need curly braces, but I say put them. Or you can have expression and multiple statements. All right. So this is just a little program here where they do they have an if statement? Yeah, they got an if. If average is greater than high score. Now, greater than, you got to remember. If I said average was equal to, what they got average equal to? 95. So if a person made 95, what would happen here? Would it print congratulations?
Maybe.
Look at it. What this say? Greater than.
Right.
Right. So that it has to be 96 and above. Right. So you can say those operators. I mean those relational operators. Yeah, you gotta make sure greater than or equal to. And that could be the difference in a person getting a loan or being denied. Right.
Right.
Because if you write code and the committee say or the board say, okay, we're gonna allow allow loans for anybody who credit score is say 750 and above, or just 750 and above, and you write the code that says if credit score is greater than 750, you might eliminate a whole lot of people. You know what I'm saying? And they might not catch it until somebody question it or whatever, and there's like, oh, I did, made a mistake. I should have said greater than or equal to. So those little things happen at times. You got to be aware. You got to be aware of it. All right. Basically, same thing. Look, if hours greater than 40, overtime is true. All right. If value greater than this, it's doing this. But it's like what? That very next line is associated with that if logic, that true part of that if logic. All right. So that's basically what they're showing you. All right. Now, this is a key too. I got an error the last time, but what happened? What they're saying is sometimes you don't get an error, and if I put a semicolon right here, what am I doing? What am I doing to this statement?
You just made the if statement its own statement. Like it's like
correct. That whole if statement is that the program gonna continue and just do what? Cut out all this off. That if statement gonna say, it's gonna say if num1 is equal to 100, and that's it. It won't compare anything. It won't do anything. That's all it's gonna do. When it see that semicolon, it stops, and then what? It's gonna start the program over. When I say over, it's gonna continue. So right now, if I run it, it's gonna add one. It's gonna declare initialize num1 to this. It's going to look at this and say, okay, I have an if statement, but then what? Oh, I'm finished with my if. I'll just continue on, add 1 to that, print out num1 and the value of num1, print out great job, and then print out num1 greater than the relational value for num1 equal in the 100. So that's what happened. And man, you'll be looking at your program and say, well, man, I know my value is not equal, but it's still doing this part. Why is it doing it? And like I say, normally somebody who got fresh eyes will say, wait a minute, you're not supposed to put a semicolon at the end and like boom, your program worked. You're like, man, I was looking at this all night, all day, couldn't figure it out. But that's what happened. It'll run, but you would get incorrect output. And remember, we talked about that. You got what? Syntax errors, but then you can have what? Logical errors. All right? Okay. So now, but if I run it, everything will just run as if I don't even have an if statement in there. So it's just going to run everything in the program.
right.
All right? Now, So what? So that's it. And not like I say, they say error. It's not necessarily an error unless you have nested, but this will give you a logical error because it's going to perform this regardless because of that semicolon. They talking about programmer style, and like I say, as a programmer, everybody gonna come up with their own style, because some people like to look at their code certain way. Then some people like to hide their code in a particular way. Some people like their code a certain way, so when they look at it, they're like, oh, man, that dude stole my code, or that's part of my code, So everybody have a style. Even if you don't think you got a style, you have a style. Some people double space after whatever. Some people create their variable names in a certain way. Some people always space between equal sign, like X space, equal space, whatever. Some people put it all together. So whatever it is, you do have a style. You might not think it's a style, but you have a style. But like I say, you adapt to a style, whatever style you like, or whatever style your company likes. And like I say, you just move forward with it. All right. Now, in this section, they talk about floating point numbers and how if you have a number that has a large decimal place, you can lose the integrity of your program because the program will round off those decimals. And look at this program here. It says, okay, A is equal to 1.5. B is equal to 1.5. But then what they did, they added 0.0000, however many zeros, 0.1. Now, if I add that to 1.5, that's not equal to 1.5 anymore. But being that the computer will go up to a certain decimal place, and I ask this question, if A is equal to B, it's going to yield true. You understand? Because it's going to cut off at a certain place, and then it's going to allow that value to be the same value. So the thing is, what they're saying is, what you need to try to do is ask if it's greater than rather than equal to, because that equal to is going to go up to so many decimal places and say, okay, yes, it's equal. But if you ask if it's greater than or less than, then it would give you whether or not it's greater than or less than. All right. So that's all it's saying about that part. Okay. All right. So we talked about don't be confused about the double equal, and make sure you keep that in mind, because that could cause headaches too. I mean, major headaches. All right. See here, every time it run this, all the students, any student that grades are compared here, they will get congratulations, because what we're doing, we are assigning 100 to average, and which makes it true, and then it's going to print out congratulations, perfect score. All right. All right. Expanding the if statement. That's the if else, right? So, well, no, it's just the if. They still just talking about the if, but more than one statement. All right. And what? If you got more than one statement you want to execute within an if logic for a true condition or either else condition, you need to embody it in within the curly braces. You have to. All right. You have to. Otherwise, your logic gonna be all off. Look here. They got what? 3 statements that they're gonna execute within this if logic. If this if holds true, curly brace, curly brace. If it was just one statement, you didn't need the curly braces. But you put them, you won't get an error. And I say put them. All right? And which can make a big difference in your program. All right? So that's what that talking about. Don't forget the braces. That's all it's saying. If you got multiple statements. Because look, if average greater than high score, if it is, you're going to get congratulations, you're going to get this, and you're going to get this. If it's not, it won't print congratulations, but it's going to print that's a high score, you deserve a pat on the back. So your output going to be what? Incorrect. You know, your code, you got your syntax is okay, but your output, and that's what they're saying here. Only that statement going to execute with this, but these statements will always execute. All right. If else, and I was saying the if else. If something is true, do this. Have your curly brace and have your statements embodied in curly braces, and then if it's not true, else do something else. So like I say, you got that. Okay, if it's cold outside, wear a hat. Else, leave no hat or leave the hat on. Okay, so that's somewhat what that logic is. Okay, if A is greater than B, add 1 to A. Else, add 1 to B. All right. So that's all it's saying. But now here, if you notice, one statement, no curly braces. One statement for the else, no curly braces. It could be problematic, like I say, as you start building onto that program. So, like I say, make sure you watch it. Now, remember that program I gave y'all the other day? I said I'm gonna look at it to see what you did. Look at this. What this is. If a number modulus 2 is equal to 0, number is even. Else, number is odd. So the code was in the book. You know, all you have to do, like I said, look through the advanced chapter. You see that
You've been bamboozled.
The code was in the book. Yeah, and like I say, but a couple of lines. Yeah. So, and then you see that, like I said, self-explanatory. A number is int. Number modulus 2. Take 7 modulus 2, get 3, and with 1 remainder. It's not 0, so it's going to print out number is odd. All right? Okay, so here, look, true, false. If it's true, do that. If it's false, because what? If you got a this or this, that's, if it's not true, then it's going to be the other. You don't have to ask the question again. Like, give an example. Sometimes what students will do is like say, if number is greater than 5, do something. And then they ask else if number is less than 5. You know, or less than equal to 5. If you don't ask if it's greater than, if it's not greater than, it's automatically less than. You don't have to what? Ask the question again. You just choose the what? The false logic, right? So you don't have to what? Re-ask the question unless you're gonna have a 2-part to it. All right. So in this example, if number modulus 2 is 0, so that means we're dealing with what? Even or odd. That's it. Well, no, not this. This is not even odd. This determining whether or not a number, you're gonna allow the program to try to divide a number by 0. All right? Because you know that any number divided by 0 is undefined. So what they're doing is they saying, okay, if num2 is equal to 0, then what? You can't divide the number. But if it's not 0, then you can go ahead on and what? Divide whatever the number is by num2. All right? So that's just a little program that kind of protects you from getting some kind of error where you divide the number by 0. That's all that is. All right? Nested. Now, remember when we looked at our example of this program, we had what? Nested ifs. But then we had combined nested ifs. We didn't have just if A is greater than B, then do this, else, if, whatever. No, we had combined it where we had and or, which we're going to get to later in this chapter. So a nested if is a if within a if. You got one set within it, nested within it, which we had here. And if I do the undo, see how many times I can undo. Let's see what happened. I could have just wrote one, but we got that example already. Set. See, that's all. Off. All right, so it's about done. I think I'm almost done. All right, and that's it. So the thing is nested. So what? I have a if, then I have one. This if is nested within this if. This if is nested within this if. This if is nested within this if. So that's what nested means. you got different levels of ifs within another if statement. All right. So you can have nested if statements. All right. And like I say, you can write a program based on any type situation. And okay, if we're doing this, if A is this, we're gonna do this. But then if this is this, we're gonna do this. But if this is this and this is this, we need to do whatever. You could, like I said, you could take your time. You could write code about any type situation or whatever. It's just a matter of sitting down and writing that logic and testing the logic to make sure it works. So here they have a program where they dealing with a loan, a company giving out loans, I think, right, or for individual, whether or not they qualify. So the first thing they ask, are you employed? The bank asks if you're employed. If you're employed, then they have another nested loop that asks if you are a recent graduate. So if you're a recent graduate, then what? You qualify for the loan. So they ask the question first if you're employed. Then within that loop, they ask if you're a recent grad. And then if you are, you qualify. If you're not, they tell you you must have graduated from college in the past 2 years to have the loan. All right? But then what? They don't even get to this stage of what? They're not employed. Okay? But we know that now what? Using and or, we could ask the question, what? If employed equal yes and recent grad is equal to yes. We could do that all at one time, right? And if both of those are true, then what? You get the loan. But then now your error message probably will be a little different because you'd have to combine both of these messages. Because you'd have to say, if you ask if this is this and this is this, do this true part. But for the else part, you'd have to combine. You must be employed to qualify and have at least 2 years of employment to qualify. So you see how, depending on how you write your code, going to determine the output prompts that you might have to give. But see, they divided it up here. If you're employed, no, I ain't employed. Hey, you don't qualify because you're not employed. You're employed? Yes. Okay. Recent grad? Yes. Or say no. Okay. I know you're employed, but what? Now you need to have those 2 years to qualify. So you see how you don't have to put this one because you know they're employed. So that's some of the things you'll learn and be able to do as time go on, dealing with your if logic and whatever, whether or not you want to ask multiple questions at one time and then give the multiple error messages, or do it in levels to where, you can be specific to actually what it is they messed up on or they need. All right? And say this is pretty much the logic, If employed, then what? A nested if they graduated. But what? If they're not employed, see, I think they didn't put the error message here because they should have had what? If employed, yes, else you do not. They should have had this information here, which they didn't print, unless they're not printing it. But this one, you qualify, but then they still don't have the error message for what? If they didn't graduate, and they're not a recent grad. So, but like I say, this program, if it's this, then if it's this, then you get the loan. Otherwise, they don't want print nothing. All right? And basically the same thing, same here, but now they added the what? They added the error message. Okay? If you're employed, yes, okay. Ask if recent grad, yes, do this and you're finished. But if not, print out this and you're finished. If you're not employed, okay, if it's not equal to Y, error message, you must be whatever. So see how they just build on the program where they had the error messages. So if you go through this and look at it, it'll help you with your programs, if you can kind of understand what is actually happening in the program. And then again, they talk about programming style. To me, this is very confusing because now you got to try to figure out which curly brace begin, where it ends or whatever, rather than having what? Your levels of if logic, right? But like I say, it's up to you and when you're designing your program, how you want to look. I would say this, many times you have hackers who have a certain signature, like they might program in this fashion because what? Their purpose is to, I wouldn't say, well, it's to like disguise and or hide, you know, or make it hard for people to what? Decipher their code, right? So sometimes you may have a purpose of writing code in an unorthodox way, you know, but like I say, it's just all up to the person who writing the code, all right? But this would look a whole lot better if you was like either teaching it or either trying to, you know, get a grasp as to what it's doing, all right? Okay. Now, okay, that's it. But then look at this. If you look at this program, and I think, yeah, we're at that. No, we're at that. Yeah, we're at that. No, we're not at that. But look at this program. This is in like the in the chapter notes or whatever, or the chapter questions. What we have here is a program, or this is a flow chart that has a nested loop, the logic of a nested loop, checking to see what grade, given a score, what is that grade going to be? So what happens is, just like if you have a number line, and notice what they did. They asked what? If score is greater than or equal to 90. So what that's saying, I'm taking every score that's 90 and above, and if that's what it is, they got a what? A A, correct? So now, if that's not true, now I'm going to check every score from 80 and above. But really, I'm not really checking from 80 and above. I'm really checking from 80 to what?
89.
80 to 89. Because what? This one checked from 90 to everything above that. So really, I've excluded, if it's not 90 or greater, I've excluded them. And when I went to the next level, the next nested if, now I'm really checking from 80 to 89. Right here, I'm really checking from 70 to 79. Here, I'm really checking from 60 to 69. But remember what I told you? If all of the situations fail, right? I've checked everything greater than 60. So anything below 60, I don't have to say, okay, now if score is less than 60. I don't need to do that because if it's neither one of these, it has to be what? Less than 60. So on this one, all I need to do is a else output the grade of F. All right? So you see how you eliminated information and it with using that nested if statement to get to either any one of those scores. All right? Because this is going to cancel out 90 and above. This is going to cancel out 80 to 89, 70 to 79, 60 to 69, and so the rest is the F failing grade. All right? And if you look at the logic, look, if test score is going to be inputted. If you input, say, 75, if test score is greater than or equal to score A. Now, look at you here. You got constant. Score A is 90. Constant int. Score B is 80. Score C is 70. Score D score, my fault. D score is 60. So here, you asking if the test score, I say we put in 75, okay? Is 75 greater than or equal to 90? Nope. So it won't print out the A. It's going to do the else logic. If, and now they could have did else if, but they just did else, and then inside the else they did the if. If 75 greater than or equal to 80? No, it's not. So then it came in here, else if 75 greater than or equal to 70. Yes, it is. Print out C, and then you exit out because all these are nested ifs, and then you just exit out the program. So that's basically what happened. And they used 78, which was still basically a C. 84 was the B. All right? So that's the nested if, all right? But now they got the if else. They could have used if else here, but they just said else, and put an if nested within that else. But they should be, let's say, take the same program. Look here, basically telling you about the program itself, taking it and using what? Else if this, else if, and we used the else if in that previous program with those numbers and the code. So here, look how much it reduced the program. See here, if, like we use 75. If 75 is greater than or equal to 90, no, it's not. Else if test score greater than or equal to 80, no, it's not. Else if test score greater than or equal to 7, yes, it is. Output C, and then you exit out. So basically, the same. You're gonna get the same results, but the code is written with an else if rather than else, and then that's the if inside the else. All right, same exact results. All right, programmer style. Which one is right or wrong? Neither one right or wrong, but like I say, you save room and it's a little more understandable with that else if. All right. Okay, and they just showing you how you go through it to get to the actual score that you need. Now, look at this. Using a trailing else to catch errors. Like I said, when you're doing the else if on my wall, if this, else, and using the else, if, whatever, else, when you do the last one, you don't have to do an else if, you just say else. It's kind of like saying, if it's A, do this, else if it's B, do this, else if it's C, do this, else if it's D, do this, then just say else that, period. You don't have to do no more ifs or anything. Else, if it's neither one of those, else this. And that's what they're saying. Now look what happened. Same exact program, but this time what? They asked what? If test score is greater than or equal to 0. So now what? They did from 90 and above, 80 and above, 70 and above, 60 and above, 0 and above. But what? Because what? A person making a negative 20 on a test, you probably can make a negative 20. Well, I wouldn't say you can, because each question have certain points, a point value. And to get a negative, I don't know how you would get a negative, right? So, but they saying anything with a negative test score is what? Invalid, all right? So therefore, you don't use else if. You're just saying if none of these held true, then else, hey, you put in an invalid score because it's below 0, right? Which would be a negative number, right? So those are some of the things that, and it's showing you the techniques that are used to validate some input, all right? Now, the if, else if, in which we have basically still in the other program. They say comparing the two, the if, the if else, and then the if statement, all right, to be nested. So it says you never have to use the if else if statement, because its logic can be coded with the nested if else. And like I said, that's what we did when we did the program. So you don't have to worry about that. All right. So look here. If funny is not equal 1, you do this, else if this. So, and if the last part, you're just doing that. All right. So it's telling you can just use the if else. Now those flags. Remember we talked about those flags, like the Boolean value. So what they did here, sales quota. Now this is something good that you can use, because a lot of times when you're writing code, you may not want to use a value of a variable, but you want to test to see if that variable has a value other than 0. All right. So look at this. You got if sales quota, well, sales is greater than or equal to quota amount, right? And if it is, sales quota true, else is false, all right? So looking at it again, if sales quota. Now, what that means is, remember what we said in the if logic. If sales quota if the value of sales quota or sales quota met here is 1, anything other than 0, then it's true. It could be 100, it could be 5, it could be 1, it could even be -5. Anything other than 0, it would be true. All right. So what happens? To give you an example, and I think they have it later on. If you had a bank account, all right, and or say I told you to write a program to input amount of a person's bank account, and using a Boolean value determine whether or not that person has a 0 balance, right? Not using any of the comparison operators or relational operators, just to see if they have a 0 balance or not. What you would do is, all right, say you have, you'd say input a person's account balance. If I put in 0 and say this was account balance, if I say CN account balance, and I put in the 0, when I do a if account balance, if it's 0, it will be false. You understand what I'm saying? If I say here, if account balance, I could have the curly braces, see out, you have a open account or a positive balance in our bank. Else, your balance is 0. All right. So what happens is it does not check to see the amount. It just checks to see if there is an amount. If it's 0, then what? It's false, which means it's invalid. All right. So what happens here? Let's see if we can write a little small program to show you exactly what happens. All right. So what happens? You can say, okay, float amount. All right. Then say see out in a bank amount. All right. And then CN amount. Now you can say if amount see out I'll just say active if it's but then if it's a 0 balance, I'll say else. All right. So, and I just wrote something. All right. So look, we're going to enter amount. Okay. When we enter amount, if I enter 0, it's going to go to this else, which is the false condition. But if it say if amount and I put in 100, it's going to say your account is active. I put in 5, your account is active, whatever. So let's run this. All right. So that's what that part does. So we're gonna run it. Okay. So like say I put in 100. Your account is active. All right. But now watch when I put in 0. Okay. Let me run it again. Let me do this. All right. That's what I wanted to. So you can see. All right, so let me run it again. And this time, I'm gonna put in 0. 0. See, your account is subject to penalties. So I didn't do anything here to compare to 0, to compare it of a number. It just, if it's anything other than 0, your account is active. You mean that means it's going to be positive. It's going to be a true condition. But if I have anything that's zero, that this expression going to yield a zero because or false, and it's going to do the else condition. All right. So that's how those logical expressions work, or those flags. That's how they work. All right. And like I say, normally a Boolean value you can use true, false, on, off, yes, no, 1, 0. All right. Normally that's how it works. All right. And it's still talking about flags here. You know, okay, if sales quota equals account quota, they setting the value to 1, or if it's not, they're setting it to 0, so that when you do your expression, you could check it. So now let's look at this and or, not a not. Class, the not, all a not does is just reverse the expression. Give you an example. Let's go back to here. If I do this, now looking at this, what I said, if amount is anything that's anything other than 0, it's true. But if I do this, I put a not here, not amount. I've just reversed that logical result. That means solve this and then reverse it. Anything that's true, reverse it to false. Anything that's false, reverse it to true. All right? Because I could do the same thing with like if not x greater than y. You understand what I'm saying? So what happens here, and I don't have x and y as variables, but if x was 10 and y was 3, 10 is greater than 3, but I'm saying the not part, so that would yield false. You got what I'm saying? I'm just taking whatever it is and turning it to be the opposite. That's all that's happening. All right? So that's what that not part does. And like I said, we went over the and or, but we're going to look at that again. Because what can happen with and or, you can build on and or based on how you group it. All right? Okay. So I'm going to just put the not here and run it and show you what happens. Now, if I put the not here, remember what we said. When we before we ran it, any value other than 0 is going to say your account is active. So let's see what happens. Yeah. So what we're going to do here, we're going to put in any number. Say we put in 400. But what it's going to say is your account is subject for penalty. You see? Because we reversed it. Okay, the true became false. So now let's go back and let's put 0. All right? And we know that what? That not reversed it. So if I put 0, it's going to say your account is active. You see? So that not just switched the true to false and the false to true. All right? So that's what that does. All right. Now, what I was looking at, and or. Now, look at this. And or. We know that with and or, we can compare values. But what we can do, we can build on it. Now you say, okay, what you mean, Mr. Sylvester? I can have two any number of values or variables. I could do something like if name is equal to, or say last name is equal to Smith, and zip code is equal to 70816, or salary is equal to 50,000, and age is greater than 5, greater than 20. You understand? I could ask all of that, but I could also group it, which could cause it to give me a different result. Okay? Now you say, okay, what you mean, Mrs. Best? I'm gonna add some values. I'm gonna say A, B, C, D, E, F, G. All right. Now, so I won't get an error when I do it. I could do something like this. Well, let me put some values. I'm gonna do 10, 20, 30, whatever. 10. All right, so I got A, B, and C, D. Oh, okay. So here I could say if A is greater than D, all right, and C is less than D, or what is or B not equal to A. All right. All right. So now, what happens is all of it is enclosed in what? An open parentheses, closed parentheses. So let's look at this and let's evaluate it. Wait, actually, now let me do one more. Okay, if that, and that. Well, let's do that one. Then we could add some more. Okay. So we're gonna have to do the first one. A greater than B and C less than D. Is A greater than D? No, that's false. So that'll be a false. And is C less than D? That's true. So we have a false and a true, which yields what? False. Remember that. Remember with the true, both sides have to, with and, both sides have to be true for it to be true. So false and true yields false. But we got to compare this one. So altogether, this yield false. So we got to say false or, and is B not equal to A. So false or true yields what? True. So therefore, this expression yields true. All right. And what I can do, I could take all this off, and the true logic here is the and I'll just use it for this. So the true logic here would be what? Your account is active. So looking at this expression, we should get your account is active, because this and this yields false. But false, these two as false or true yields true. So if we run this, see, we got your account is active. So see, it did this part first, compared this to this, and got the and part. Then it did whatever the results from here, or this, and you got your or results. Now let me show you something though. Let me move this down a little bit. I'm gonna show you something. Now, if I were to, where is it? Can I? No, because this, and this. Let's see. This, or yeah, I'll do it like this. I'll put this here, all right, and then I'll add a parentheses here. So now what I've done, I've grouped it. So now, just like with mathematics and your operations, you have to go work from the inside of the parentheses outward. So before I could do the and part on this, I have to solve this. So is C less than B or than D? True, right? Or, now we don't really need to do the other side, because the or says what? If any side is true, it's automatically true. So let's just do it anyway. Is B not equal to A? That's true. So true or true still yields what? True. Now, is A greater than D? That's false. So false and true yields false, because that's an and here. Both sides need to be true. So false and, so what? The first time we did this first, and then we did this. But this time we grouped it, and we did this first, and we got what? We got true, but then this is false, and this and. So true and false yields false, so we're gonna get this result. All I did was what? Grouped it in a different, I grouped it, showing that we need to do this before we do that. and we gonna get a different result. And if we look at it, it should say your account is whatever. See, your account is subject to penalties. All right, so the grouping does make a difference, just like it does in an arithmetic expression. Okay, so you got to be careful. Now, I could build upon this and have all kind of other ands and rs and grouping those ands and rs based upon what logic I want to check. So you can make it large as you want, because I can even go here and say and then continue on with, but I got to group all of this together, because whatever I have in the if has to be in the group. All right. So, and I can start doing all kind of other stuff for another logic for whatever. And that's how they write code, to filter out data and do whatever. So you got to understand it. Now, let me show you why I showed you this. On that quiz, let me go to to this. All right, I put out a quiz, all right? And the quiz is combined assignment operators. All right, so if we look at this, I think this is the right one. No, I didn't show you that. Well, I'll take that quiz off. We'll do that next time. All right, I'll take that one off. But I thought I had my and or quiz, but I may have taken that one off too. Let me see. And or. Oh, here we go. Oh. But I saw it. No, I don't have it in there. Yeah, look, it's here. I got the wrong quiz. I'm gonna take this one off. I need to unpublish this one. Come on, I'm gonna unpublish that one, and I'm gonna publish this one. All right, this is the and R, and I'm gonna show it to you. All right, looking at this quiz, I'll make it do next week's sometime. Let's see. All right. I need to move this there. All right.
You have the available from a later date.
Oh, wow.
Today is the 30th.
Yeah. All right. So, and I'll publish that one. I'll take the other one off. We're going to go over that other one. Yeah. Now, look at this. I gave you variables with different values, okay? Now, and what I'm going to do, I'm going to go to the, I could do the preview. All right, do the preview. Now, look at this. You got B greater than 56 and C not equal to 3. All right, that's grouped, right? Then R, Y not equal A. So, looking at this, whatever this is going to result to, if you're looking at it, right, you got to do this first, correct? But really, all you need to do is check for this, right? Because if this holds true, it doesn't matter what this is. Everybody understand that?
Gotcha.
Everybody understand how I came to that reasoning?
Yes.
No, right. No matter what this is, you got to compare it to this, and you're doing it to an R. So Y? Y is what? Well, really, if Y and A are not equal, 26 and 28, then you know that would be what? True. You understand? But you can't go through the motion. Look at this, get the result, and then this or that, and you get your result. And if you look through it, like I say, all of them basically the same. You're just gonna keep having to look back at the, or you can write them down, the expressions to see what the values are. And always go back and look at these values, all right, to answer each one of the questions. All right, and it just kind of getting you a feel of writing you know, your and r's. So like I say, if name is great, if name not equal whatever, or zip code greater than whatever, you know, you could add any kind of question. Not equal to, greater than equal to, less than equal to, not equal to, equal to. So any one of those relational expressions, logical expressions can be used. And that's that. Then see again, remember on my website, we had true and true yields true. Well, true and true. True and true yields true, the bottom one. But true and false yields false. False and true yields false. And false yield false. But like I said, you got to work with each one together. It should be one side against the other side, then the next one on the next one. So it's like you P and Q. You got to be able to compare those each side. All right. So look at this. If employed equals Y and recent grad equals Y. So you got to do this equals this. Check, see what that is. And now you got your and, mean what? If this is true, this has to hold true. Recent equals whatever. So that's pretty much how it works. All right. The OR logic, same difference. You cannot do this. Temperature, you can't write it like you might write a math problem. Temperature less than 0 or greater than 100. Can't do it. You got to know what it's comparing on both sides. So look here, temperature less than 0 or temperature greater than 100. They got to have something to compare it to. Got to have it. All right. And the OR logic, true and false is true. False and true is true. False and false yields false. And true yields true. All right. So, and that's basically though the not operator, we looked at it, not just reverses it. Not true yields false. Not false yields true. If I have an expression, whatever that expression yields, if I have a not in front of it, it just reverses it to whatever it's not. All right. Okay. The precedence, you got your not. The not just take whatever and reverse it. But then you got your and then you got your or. They're both pretty much on the same level. You know, you got to work within the parentheses and then from left to right. All right. Like I said, you're not just reversing it. This, you're going to do this and this, and then you get your result. All right. But this saying is the same as this, but many times you want to group it to kind of keep it organized. Because sometimes when you start adding other code or whatever, it makes it kind of like it's jumbled. You put those parentheses and you kind of see it. But if I put this inside an if statement, I would have to have curly brace, parentheses outside or around everything. You understand? Because everything has to be the whole group for if or while or whatever. All right? Okay. All right. So this and this, or this and this, and this and this. Okay. Right. And like I said, we went over checking the number range because your program is doing that. And it's showing you if you want to include numbers, X greater than equal to 20 and X less than equal to 40. So that means from 20 to 40 is what I'm looking for. Okay, that's the range I'm looking for. But then you could check outside. All right. If X is less than 20 or, now see, you're not using and this time. We got if X is less than 20 or X greater than 40. All right. Okay, so that's how you would exclude, like say exclude that range that's in the middle. All right. Now, so this here, this pretty much is like if X is less than this and X is greater than that, it's like 5 can never be less than 20 and greater than 40. You understand what I'm saying? So you'll never get that, you'll never get a true condition for that. All right, it'll be false. All right, so you gotta pay attention. So now they're just showing you your logic, what true and true, false and false, true and false, etc., which will be looked at the Boolean table. Now, menus. We never wrote menus, but menus are not that hard or anything. What it is, if you look here, a menu is just you using the CL statement to list options, right? Now, once you list your options, and if you look at this, they got 1 this, 2 this, 3 this, 4 this, and then enter your choice. And then what? See in choice. So now a user would see this screen and they would enter either a 1, a 2, a 3, or a 4. So when they input their choice, based upon their choice, if it's equal to 1, you're doing something. And now you can make it more fancier, in which we could do later on in the class or even the next semester. You can create a module, right, where it'll go and execute a module rather than try to execute something that's within the program. All right. So looking at that, you would like do something like this. All right. So I have I could do something like this, take this out, and I'll say, okay, I could do int choice. All right. Then I could say, okay, not say see out, yeah, see out, and I'll say main menu. And I'm just writing something, nothing fancy. Yeah. All right. And then I could say see out, I'll do this way. If I do something like this, 1, 1, let's say add numbers. If I had some code to add numbers and see out, and I'm just creating something. See out. Divide, let's say multiply. And then I could say choice, see out. I could do a space. All right, and a choice. And then seeing, all right, so this is just a menu. And like I say, you would have something like a if logic, like if choice is equal to, gotta use double equal, if choice is equal to 1, all right? And I could just do something like, okay. Let's say, see how. To add number. And I'm just putting this to know what we chose. All right. And then I say, I could do an else if I want, else. If, say CL. Should what divide. Okay. And then the last one, what did I do? Oh, end number. Last one, CL. Should put That's it. To multiply. All right, 1, 2, 3, and then inline. All right, and then I could say here. Oh, not here. Remember I told you about the error message? I could do just a else and do a see out. You have entered. All right. So, right. So now, I have this if. It's reading in a choice, but it's going to display that menu first. It's going to display the menu, allow me to input a choice, and then based on the choice, it's going to say you chose whatever. But see where I have, see how you have chose whatever, I could make it call a function, just like we call that head function in when we're doing our header file. You could call a function that's going to add numbers or do whatever you have to do or whatever it is you want to do. So let's debug it. I mean, well, let's run it. Okay.
Does C++ have a built-in GUI function? Like, is that something you can do through the like?
Ooh, now I remember they had something they called cursors, but I never programmed using it.
Yeah.
Right, and like I say, it was, but I never programmed, dealing with the graphical interface with visuals. Yeah, I never did it. Now, I think you can embed a lot of C++ code into like Visual Studio and other applications that do have that graphical interface. Yeah.
Right. Would you be able to like just insert like files like JPEGs and whatnot to display by like
Oh yeah, in C++.
Yeah, in C++. Like, would that be a way to do it, or?
I think you can do that. Now I know you familiar with DOS?
I know of it, but I don't know much about it.
What happens is with C++, I'll show you. It's a command called system, and like I said, it depends on what operating system you're on as to what command you use. But with Windows, there's a command called system, and what it does, it allows you to break out of the C++ environment and go into the Windows environment and execute something.
Gotcha.
Yeah. So watch. I'm gonna put in a 6. See, you enter the invalid choice. All right. So I'm gonna run it again, and I'll choose another one, a valid one, and then I'll show you what I was talking about. Then I'll put in 2. See, you chose to divide numbers. All right. So what I can do is though, watch down here.
Could you by the way, could you also do like put the return value and also an if statement? So if you choose that as a menu item, that will then close the program.
Yeah, you could put that return value anywhere in your program. But what happens is whenever it hits it, no matter where in the program, it's gonna exit. Yeah. Right, it's gonna exit out. Right. Gotcha. Right, yeah. Now there's something called system. SYSTEM. Now in DOS, there's a command. I can do a dir, right? Mm-hmm. The dir gives you a listing, a directory listing of all files and folders in your default folder that you're working in. So when I run this program this time, watch what happens. What I did. Oh, I want to do that. I want to do this. All right. I clicked on something, man. Okay. All right. So say I'll do a 3. All right. See? Now look. See that DRR directory? It didn't do that last. So it breaks you out of whatever. Now let me see if I can. Is there a command? Is there an application? Let me see what application. I'll say I'll do paint. Let's say I'll do paint. All right. Because paint is something in Windows. Let's see what happens. But they're probably gonna need to know where it is. Probably gonna need to know. Yeah, see, what command, what I could type. I'd have to see with DOS, with Windows, normally you have your pat set and you can type in just a command and it's gonna automatically search for it and find it for you. But I don't know what I can type. I could create another shell. You know, it's anything in DOS you could do. Because if I do CMD,
That's like what C++ is based off of then.
Right. Yeah. So if I do this, what's gonna happen is it's gonna run, but it go. What did it do? What did I do?
I think you did a diagnostic.
Yeah, I think I'm clicking too fast.
You getting antsy.
Now, something, man. Let's see. Let's go debug. Oh no! Come on. Oh no! I don't want that report. That's what it. Okay, like you say. Okay, I'm gonna go here and debug. All right. What are they doing? Okay. All right. So now watch when I type. Watch it to open up another screen. They didn't open up the screen, but it put me in, like say, the window. That's the CMD window, which is this box here.
Gotcha.
Right. But yeah, that it allows you to break out of. But I know I use PHP, and a lot of the code styles, the code you can use in C++ code, you use in those programs. So you can interject that code inside, because a lot of your servers and all that, the operating systems are built on C++. And Unix and Linux, they never really kind of trailblazed after the graphical interfaces, because a lot of people who use those those operating systems, they were like command line prompt people. They'll type the command from the prompt and do everything from the prompt. But they kind of getting away from it and trying to do a lot of other like the word applications and other stuff now. Right.
Well, they have OSs built off of Linux, so I figured there has to be some kind of thing where they can do graphical stuff.
Right. And because I think Ubuntu is one of the Linux kernels.
Yeah.
And that they and like I said, you can switch back and forth to their little graphical interface, but there's not much you can do. But they do have software, and they're kind of getting better, and they kind of get better with it. Yeah, but I like I said, I've never really programmed using graphical interfaces with C++. Like I said, I know Visual Basic, it does a lot, because a lot of the pop-up windows you get in Windows, that's that Visual Basic and stuff.
I figured I'd ask because I kind of do have like an interest in video game designs, and I would probably have it as a hobby, like while I do a different job.
But see, what they do is, I think what happens is they use the Python and the other softwares to build, and then they use, if they need to inject code, like I use PHP with my website, and I don't know a lot about JavaScript, but I use it to validate my entry, my data entry fields. You know what I'm saying? So it's like you can take an application and then inject other code in it to satisfy what you need to satisfy.
Gotcha.
Yeah.
Okay.
Because see, with C++, I would say C++, like the Unix and Linux, it's like, I know I was a DOS person. And when I first started using DOS, I knew, okay, to pop out the CD, you press a button, do whatever, right? All these other things, you do whatever. But really, a lot of those things are command or can be command given. And when I started using the Linux, that's when I realized anything that's done when you click on with the mouse, you can do through commands. Because Linux, that's how a lot of those programmers do. They just type the command, mount a drive, eject the CD, do whatever. You know what I'm saying? Yeah, they got all those commands in their head and they just use them. Whereas when you're on a Windows system, a lot of time you're lazy, just click, 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 click.
Hey, laziness is the mother of invention, you know?
Yeah, I tell you. Yeah. Yeah. And like I say, this part talking about validation, I think that's the last part. And when I validated that last part where it did the screen, the menu screen, and what? If they didn't type in the right one, invalid choice. And that's all they did here for the test score. Every test score up until greater than 0, greater than or equal to 0, and anything else, if it's negative, it was false or it was invalid. Yeah. Now, when you comparing characters, like I say, your numbers, they have a certain value. Your characters, capital letters, lowercase letters, they have values. That's how they know how to sort information. Because the A is less than B, less than C, less than D, on and on. Lowercase a is less than lowercase b, less than lowercase c, on and on and on. So they have their ASCII value. And when we saw that ASCII table where it had those values. All right. So what happens is the same thing here. We got A and Z. We know that if we wanted to check to see if a value we inputted was between A or like say of either a character, we could type it in and check to see if it was greater than, if it was uppercase, greater than equal to A and less than equal to Z. You understand? Because what? The value of that character would be in between that range of the uppercase A and the uppercase Z. But then there is a header file that you can load that deals with string that checks for if a space, if uppercase, if lowercase, if a digit, if a special character. So there's functions already built into the C++ compiler that checks for that too. But they just showing you here how in a dinosaur way it's actually done. You understand? Right. So you can check and compare character data. All right. But then string data. Now, string data is compared also, but it's compared character by character. Example, in the book gives like Mary and Mark. Mary, capital M, both of them start with capital M. Okay, they equal at that point. Both of them have a lowercase a, they equal at that point. Both of them has an R in the third position, they equal at that point. But when you get to the last letter, the K and the Y, K, lowercase k come before lowercase y. So that's how it would check to see if one was greater than or less than the other so that it can put them in the order or whether or not they equal or not. All right? But if you look at this, look at string A equal ABC, string B equal XYZ. This one would be lower than what? This one. Because what? Less than this one because A come before X, right? So it would be automatically less than the other one. All right? And then we look, and this is the example I was just telling you about, Mary and Mark. It'll compare each one till it get to a different one, and then that's when it would know whether or not which one was greater than or less than, right? Because it's comparing each individual character position, right? So Mary would be greater than Mark, and Mark would be less than Mary, right? Okay, all right. Just because of the K and the Y, all right?
Right.
All right. So, what is this? What's this program? Oh, this program actually dealing with this string here. All right. If part number, CN part number, and then you input the part number. But notice here. Notice what they did here. They got fixed, show point, set precision to 2. So what that means, anything they print or float or double will have what?
A precision of 2 after the decimal.
Two decimal places. Anything on float and double, 2 decimal places. So you see, and they what? They just did the C out for that here, and they didn't have to put it in the original, well, in the actual C out statement, because they set it, and it's set and it's done. Right. So it's checking to see what the part number is, and based on that, then it gives them the price of whatever. And I think price is set here. See, the price is set here with 1 decimal place, but it's going to output with 2 decimal places. All right? Okay, and y'all can do those conditional operators. Now, look at this. This is somewhat the same, it's a shortcut of using if-else. Look at this. It says x less than 0, question mark, y equal 10, colon, z equal 20. What that says is, if x is less than 0, then y is equal to 10. Otherwise, z is equal to 20. So, if x was 5, it would assign 20 to z. If x was -4, it would assign 10 to y. You understand? So that's just a shortcut. And I could type it up right quick. There's something that says, okay, let's see. Take this. We could take all this. All right. So we take this out. And we'll do say int, say x equals 3. Now, you could say, and I got to do y, and z. Right? So I got those 2. They don't have a value or nothing. So I could say x, I'll do less than 2, all right, question mark. Y equals, I'll set y to 100, colon, z equal, let's say 45. So the thing is, and now I could see out x, y, and z. See out. And I'll just do that. I'll do x, y, and z. All right. So now, so what? It says if x is less than 2, we're going to set y to equal 100. Otherwise, we're going to set z equal to 45. Now, we printing z, but we're not giving z a value because what? It only going to give z 45 if z what? I mean, if x is greater than 2, right? If it only going to set z to 45 if this is false.
Oh, okay.
Right. I know I said it, like the backward. So let's run it. We run it, and it might give me garbage for z, being that I didn't give it a value. But it's going to give y 100. See, no. Hey, I don't know if that's, let's see, let me run it again. It might be something on my part. Yeah, see, let's see. I think it's because, no, that's not right. Let's see. Z equals 0. Let me set them to 0. Because I'm trying to print them and they don't have a value. All right. Okay, let's run it. See? So, I was trying to, wait. Wait a minute. X less than 2. 3 is not, okay. So that's false. Yeah, you was right, man, Mr. McDowell. If 3 is less than 2, it will do this. But no, it's gonna do that one. Right. You was right. Yeah. Okay.
I was
So
confused because it was like I imagined there would have to be like the exclamation, like the not.
no, right. And I was thinking I was doing it where y was equal to 100. Yeah, I was messing up. Yeah. So now let's change this. Let's make this 13. Right.
Oh, well.
So now x gonna be greater. Wait a minute. If
You
x
need to
is-
make it
no,
less.
no, yeah, I need to make it 0 or something. Yeah. So now, okay, because I didn't use y. So I made x 0. So now y gonna be 100 and z gonna be 0. So debug it and let's see what happens. Yep. And see. So you see how it works? Rather than doing if this with the parentheses, whatever, you can like I say, use this little shortcut. And like I say, it'll work just the same. You know what I'm saying? It's all in programmer style. You know, right or wrong, I could rewrite this to say if x less than 2, then what? Then what? I want to say what? Y is equal to 1, equal to 100. Otherwise, so you see it just a little z equals 45. So this one line here and these few lines here is equivalent. That's the same thing. They are
I think
equal.
before it was not printing z as 45, despite x not being less than 2.
Oh, it was.
It was? Okay, I might have just missed. Yeah, I just
No,
missed it.
remember what happened? I was getting like a system dump because I didn't initialize the values.
Oh.
And then once I initialize them, so watch, I'm gonna put it back to 3, and let's run it. And so, because I got that error twice, and then I had to give them a value.
Well,
Yeah, watch. Well, wait, let's see what happens.
you had the second part, the other if.
I did the what? Wait,
You got it. I think you got to get rid of those.
Yeah, because it's gonna do the first one, and it's gonna redo the next, do it over. Yeah, I just should have left it. Took one of them out. Let's say run it. What is it doing? Okay. No.
You still haven't taken it out. The second.
But I thought I changed. See, if x is less than. Oh, I did. Oh, but then here.
Oh, right.
Yeah. So let me take this. I'm gonna take this out though, because that's confusing us too. All right. So now, say we had x as 2. Well, it is good now. Let's see. Okay. Now, so 2 less than 3. That's true. So it's gonna print the. Well, no, we want to do the other one.
Yeah.
Yeah. We want to make it where let's make it 4. So if 4 is greater than less than nope, and it's gonna do the z. All right. So yeah, so that should give us the z part of 45. Where? Okay, there you go. Yeah, see, that's the 45.
Yeah.
Right. Let me see why it's not. It should pop up. Okay. Yeah, there you go. Right. So see, yeah, the z is 45. Got 4, 0, 45. Right. Yeah. So, yeah, and like I said, it's just a shortcut. Like I say, you might use it, might not want to use it. It's just up to you. And this just explain how it is used. I don't never give a program to do it that way, but you can. And look, you never go wrong with parentheses or curly braces. You know, it just grouping. That's all. So it doesn't create errors unless you're cutting something short. If I take this parentheses and put around here rather than right at the 10, put it here, then it can cause issues. You know?
Gotcha.
Right. Okay, so but they basically that's the little logic, same little logic that they have here. All right, and then they have it in the program. What is the program? Where is that? It should have an example. But they had an example in here. Yeah, right here. See, hours is equal to. So now what they did this time, they said hours is equal to, if hours is less than that, do that. It's going to be hours, hours or min hours. Otherwise, it's going to be hours. So in this program, what it did was, no matter how many hours you work, if you had a minimum of 1 hour, they're going to give you 5 hours work. It's kind of like just to show up to work, you're going to get X number of hours. But if you work more, you're going to get the more. So that's what this does. It'll assign, based on this expression, it'll assign min hours to hours, or it's going to assign hours to hours, or let hours stay the same. All right. So that's just some little tricks or whatever you can do to kind of keep you from writing a whole lot of code to accomplish something. Yeah. Yeah. Okay. The switch statement. The switch statement is good to use so that you won't have so many nested ifs, right? What happens with the switch is normally it's case switch. You can just say switch whatever, and then do whatever. So look at this example here. It says, okay, you choice. It says C out, enter A, B, or C, right? C in choice. Now you can enter any letter, right? But it's telling you enter an A, a B, or a C, right? So now you input a choice. Now check this out. Rather than do an if, you do a switch on the variable, okay? We're going to enter A, B, or C, but then it's going to say switch choice. Then you do a case, okay? Just if it says, if it's A that was typed in, we're going to say you entered an A. But then look what happened. They say break on out, okay? Case, if it's a B, print and output, you've entered a B. Then break, get on out. And then case C, you've entered a C, break on out. Now, so rather than have if choice equal A, C out, you've entered A. Else if choice equal B, C out, you've entered a B. Else if choice equals C, you've entered a C. Else you did not enter A, B, or C. You see how it's a little more clearer. You don't have to have an if. You're just saying, okay, if it's an A, do this, if B, do that, C, do that. And then look, you can have multiple statements inside of this. From this colon on, colon, you can have statement, break. Here, statement, break. So if you're doing calculations or whatever, you can do all that and then break. Now, one issue students have, or new programmers have, what they do is they don't put the break statement in there. If you do not put the break statement in there, if I input the letter A, it's gonna say you've entered the letter A, but it won't break out if you don't have it. So if I took this out, it won't break, and then it's gonna go letter B, case B, and it's gonna print out you've entered B, and then it's gonna break. You understand? Yeah. So you got to be aware, because what'll happen is it'll perform everything until the break and then break on out. So you got to watch that. But sometimes you want that. Sometimes you may want it, because give you an example. If, and it's down further in the chapter, if you wanted a user to input the letter A, but you didn't want them to have to choose between the uppercase and lowercase, you could have right above this case, single quote, little a, single quote, colon, and then case, single quote, a, single quote, colon. So what's going to happen? It'll look at the first case, oh, it's an A, then it's going to get to the second one, and it's going to say, C out, you've entered an A, and break, and it breaks out. So that way they don't have to do the shift A, or they just do an A, no matter if it's uppercase or lowercase, and it's an A, and it's done. All right. So see, it's a little bit easier than if statements. little bit more cleaner, but like I said, it's all up to the user as to how and what they like. And see here, the break kicks you out. If we go further down, all right, see what they did here? They took the breaks out, correct?
Yeah.
Now what happens? Okay, they typed in what letter? They typed in the letter A, but look, you entered the letter A, you entered the letter B, you entered the letter C, you did not enter A, B, or C. So it did all of them because there was no break in it. You understand? So you got to make sure that you handle those breaks. But now look at this one. It did this one. Okay, when they entered the C, all right? They entered the C, and then what happened? It start here. It says you entered C, you entered a C, and then what? You did not enter A, B, or C. So it continued on from that point forward.
Yeah.
It didn't go in there. So you got to be mindful of that. That when the case statement, all right? And look here, this dealing with a remote, dealing with buying a certain package for a television. So it's like if you got the 300, it's gonna perform this, all right? Then it's gonna if you got a 300 package, it's gonna perform picture and TV, stereo sound, remote, and then break. If you bought the 200 package, it's gonna start here. Once it get in there, it's gonna perform this. It's gonna until it break. Perform this, and then it break. If you bought the 100 package, you bought just the TV and the remote. You bought to get the remote, and then you break. So you see logically how it works. Once it falls in, it's gonna perform everything from that point till it hit breaks. Everybody got that?
Yep.
It's gonna continue on no matter what it is. And once it falls in that case, that first case, if they don't have a break, it's gonna perform every case until it hit a break. All right? So that's why they did it this way, because what? Oh, TV and picture, but then I'm gonna add all other amenities that come with it, because it's gonna perform all of them till it hit the break. If I bought just the 100 package, series package, oh, that's just the remote, the TV with the remote. So it don't fall in here, don't fall in here, falls in here, the remote, and then break. And if it's neither one, it's just gonna say you only chose. You can only choose 100, 200, or 300. All right. So that's the case there. And look, remember I told you about the uppercase, lowercase letters. See here. So rather than doing the uppercase, then the lowercase, if this and that, if that, no, you can just do this. Now, this would be equivalent to saying what? If choice is equal to single quote lowercase a, or choice is equal to single quote uppercase a, correct?
Yep.
Because there's one or the other, right?
So is it not possible to do a or within the same case thing?
You can do, you can do an or, but you can remember I told you could add code here?
Mm-hmm.
So you can do other code. You can have other lines of code till it get to that break, right? But you can't do it in here, no.
Okay, yeah, that's, yeah.
It's just checking for that value, period.
Gotcha.
Yep. Yes, right. Because it's not checking to see if it's greater than, not checking to see if it's less than, not checking to see if it's not equal to. It's checking to see if it's that value.
Gotcha.
Right. Yep. Oh, yeah. Yeah. And like I said, you can even use it, they say, with the menu. So now you got the menu set up, and then look, case adult, and then what? All of this. Look, see, remember I told you could put multiple statements inside that case?
Mm-hmm.
For how many months? You then see out for how many months, see in the number of months, then calculate the charge, then print out their total, break on out. So you can have whatever valid C++ statements inside that case that you want. You can even call a function, tell it call a function, and it'll return back and continue on and whatnot till it hit the break. So
Gotcha.
there's many different ways you can code, many different ways. All right. So blocks. Now this is key, class. And what this section basically talks about is we try to teach you when you're coding to what? Name all your variables at the top, correct? Because what happens? If I have an issue with my variable, the data type, the name, spelling, or whatever, I know I could go what? To the top of the program and find it.
Yeah.
Sometimes though, sometimes a programmer may introduce a variable where they need it, which can cause havoc, you know, because now you're like, I know I got this variable declared, now I got to try to look through my code to find out exactly where I actually declared that variable. And you know, there's searches and whatever, but I'm just saying it's not like, oh, I'm gonna go to the beginning of my program. This is where my variables are declared, and hey, I can see if it's right, do whatever. Now, if you look at this program, the variables are declared at the beginning, and then what? The variables are used throughout this program. That's all they're showing you here. And like I said, they got if logic or whatever. But I'm gonna take you further down. What happened, what they did is, look at this code here. Well, let me go back and show you the difference. This one, they got what? Where is that? What is that? Oh, when they got the year, they got year here, and where is income? Double income. So they got them both. Well, they did it the same way there. So they got int income or double income right before they used it. They got int year right before they used it. All right. So here they did pretty much the same thing, double and int. But what happens is when you do that, if you look here, year is declared where? Inside the what? That if statement, right? Yeah, or that if logic, correct?
Yep.
See here where I got int year? What happens is year is only known from this point to this point. If I try to see out year anywhere else outside of this if logic, it will not be recognized because it's only known where? In that block of text. Everybody understand that?
Yes, sir.
That so it's like, and now you can do program that way to control you from what? Trying to use a variable somewhere else when you only want to use it there and don't want to change its value. You know, you can do that. But once you declare it up here in the main, then it pretty much can be used, you know, anywhere. But when I create it in that body or that block, it's only known in that block. And you'll see that when like I say, you'll be able to see it. We have a program further down where they introduce a variable in the main. Then they have the if logic, and they have the same variable inside that block. They printed out the variable value outside the block in the main. It got a certain value, and then they printed it out inside the block, and they got the value from inside the block. So it's like I say, it's two different areas, and the value cannot change when it's in that body, in that block. So let's say variables with the same name. When a block is nested inside another block, a variable defined in the inner block may have the same name as the variable defined in the outer block. All right? As long as the variable in the inner block is visible. All right? However, variables in the outer block will be hidden, meaning you can't use it. All right? So look here. Like I said, you got int number. All right? Then you did whatever here, and then all of a sudden, this is another block, right? This is the main block. Then this is the if block. And then they did what? Int number again. But I thought we couldn't declare a variable more than one time. But if it's in a different block, you can. Right? So what they did, they introduced number again. They compared number, but this number is being compared to what? to this value that's being inputted. But then you declared another variable of the same name, but it's in a new block. It's inside these curly braces. And now when you input a number here, you can output this number, but it's going to be the second number that you inputted that you're going to get that output. And then when you go back out, when you get out of this, now you're in the main block, you can output number again, and it's going to output the value of the outer block. Okay? So I'll write something similar to that and to just show you. So if I do something like that, say int num equals, I'll say 100 at 100. All right? And then I'll say something like, I'll just say int t equals 3. All right. Then I'll do something like if, I could use num. If num is less than 1,000, all right? Then I could say, do something in here. I could do int number or num. Int num, okay? Then I'll do cout. Cin num. Now I'm getting another number. Now what I'm gonna do cout. I'll do a slash n. Okay. Second number. No. All right. All right. Now, but then when I get out, I could do cout. What did I do here? Oh, inline. I'll get it. All right. All right. So, like that. So now, when I run this, the first number, I just initialized it to 100. The second number, we're going to type in a number. All right. So let's debug and see what happens. Oh, you know what happened?
Let's see something.
If number less than one, less than or equal to. See, because it ain't gonna never go in there because it's 100. If num, no, you're right. Less than or equal to. That'll make it go in there. All right, that was my fault. All right, so here we go. Enter number. Now, num is equal to 100. Let's pull this down and see. Num is equal to 100. So say we put in 5555. You know, see, look, the second number 5555. As long as we was in that block, it's 5555. Or if we add it to it, multiply it, whatever. But then no matter what we did to num, when we got out, it goes back to what? Its original value. Because we're in that other body, a block of statements. All right? So you got to watch that with C++. All right? You got to watch it. So this is the number that we typed in, because we assigned it 100 here. We asked if it's less than 100, fall into this loop. So we know it was less than 100. We fell in the loop. We assigned it a new, we declared a new num, all right? With num here, int num, and here, int num. But we're in a different block. And then we inputted a new value, printed out that new value we inputted, and then we outputted the original value about getting out of the body, and then we're in the body of the main. where int num is known here. All right. So you gotta be careful of that. All right. Gotta be careful of that. All right. So anybody have any questions? But I wanted to go over the chapter. I'm glad we had all this time. And some people I know they probably had to go. But any questions?
No, sir.
All right. So hopefully, like I say, hopefully you done got the pattern, the assignments and the quizzes, available, your tests available. So you can take your quizzes, take your do your assignments and whatever, and then take your test. Make sure you take it in before the deadlines or whatever. All right. And like I said, I'm gonna look at these programs from that you did by last night, and I might reopen them, because I want you to do them good. I want you to do the header files. I want you to understand the logic. Once you get one program accomplished and say, well, man, okay, I got it. You build your confidence. But if you never get any of them right, it's like, man, what am I doing? Why? What's going on? I want you to get it. And what I'm gonna do, I'm gonna post this session. Now, it might be kind of long, but I'm gonna post it, and then you'll be able to go in and look at this one also. All right. But
It's not too long.
Huh?
About roughly 4 hours, a little under 4 hours.
Yeah. Yeah. All right, man. But y'all have a good one. And like I say, try to get your homework done and stuff. All right.
Yeah.
Hey, also, I'm gonna have to I'm gonna have to send out an email. They got this, like if you need an extra course, it's not a course that goes towards your AS degree, but next semester I'm gonna be teaching Unix and Linux class.
Okay.
And if you want to get in it, you can get in it, and like I say, it'll be next semester and whatnot. And if you like it, like to be in it, hey, get into it. I'll try to teach it as much as I can about Linux and stuff like that, the commands and things of that nature and whatnot, so that when you get on the job, you have some inkling. Okay, Linux, okay, I kind of understand. I kind of know whatever. So you'll be more familiar, with it. All right?
All right.
All right, so I'll see y'all next class period.
All right. You have a good one.
Yeah, have a safe 4th of July.
You too.
All right. Right there. Going down here. Okay.